Been doing this for
basic geometry.
fucking years.
Flat Earth.
You didn't fucking get it by now. Get the fuck out of here.
Geometry. This is basic geometry.
It is.
I called you a flat earther,
My name's Ramsey.
insisting that your flat Earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a five-sided square question mark?
You're a universal horizontal waterer.
You're drunk.
I called you a flat earther.
You want to experience true level? Do you? Yes. You want to experience true level?
That auto level is establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Yeah, it's gonna look super flat.
All right, come on. Wow, it's so.
Three coplanar points.
Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
If you're into math, there's a certain shape where you could make a five-sided square.
Are you suggesting that horizontal can't curve?
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Morty. Go to school, Summer. I'll go in Morty's memory and do a little.
Randy, come on, that's a globe. And he eventually just gave up and said, yeah, I agree, it's a globe.
Geodesy is a continuous string of infinitely small, straight lines.
Yeah, true level, bitch.
It's really flat and level now.
Randy, come on, that's a globe.
Yeah, true level, bitch.
Randy, come on, that's a globe.
Lamps to the cosmic slaughter! Well, you seem to be in charge of what I get to remember. Why? Good question.
Randy, come on, that's a globe.
I'll go in Morty's memory and do a little. Wow, it's so. Oh my god! Oh Christ! Yeah, true level, bitch.
If you're into math, there's a certain shape where you could make a five-sided square.
Randy, come on, that's a globe.
Yeah, true level, bitch. Wow, it's so. Oh my god! Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
Yeah, true level, bitch.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No. Okay, I'm going to bed. Right.
Okay, so
I'm going to bed.
that level is horizontal is good for you then, right?
I agree. I agree. Level's horizontal. All
Sweet.
Right,
True level, bitch.
Perfect.
Wow.
Nice, mate.
Nice.
Just for that. You flipped it, man.
Yeah, true level, bitch.
And we are live. Welcome everyone. It's I guess it's Model Affliction Monday. I don't know why I didn't do the Model Affliction bit. Mainly because True Level. I'm redoing the True Level. I'll probably go after, but you've not heard that yet, have you, Buster? Got rid of the ranty and everything. I put Rick and Morty in on the original. Video's not done yet, but sort of doing that. Yeah, so today we're going to be going over Jesse Kozlowski and the Lake Pontchartrain Bridge. And clipping out a few bits for True Level Bitch 2023. Modernize it. We're doing a remix as well. Got two cuts of True Level Bitch. Well, one looking for the truth, brackets True Level Bitch, and the other one will be True Level Bitch, brackets looking for the truth, I think. We're inviting people to come and have a go. I want to get everybody involved from the server on these remixes for True Level Bitch. Yes. So what we've decided to do is, because there's a lot of people that, you know, haven't been around all the time and then unaware of the early days of how we came to be where we are at the minute. We're going to go over a thing with Jesse Kozlowski. And we're talking about Lake Pontchartrain Bridge. But I mean, I came into this because I was looking to have a word with Jesse Kozlowski, because obviously I'd done some surveying. I have experience within surveying. I have training, 2 years of it within the construction industry. And I mean, it may just be me that has these qualifications and I was asking these questions, but I have to point out I'm not a flat earther, right? And I never was a flat earther, but I was asking questions of these model defenders. And because you ask questions that maybe they can't answer, maybe they were the ones that said some stupid shit and I asked them questions because it just seemed like stupid shit that they were saying. So, way back in the day, Jesse Kozlowski on Twitter, there was a guy called Sly Sparkane. Now, I don't know whether you know much of him, but he was one of Red's Rhetoric's mates. And he had this water level test. And me questioning him about his water level test led to Jesse Kozlowski. And as far as I was aware, that Jesse Kozlowski is he was the only globe surveyor around. There was another guy called Aaron Burrell, who's blocked me on Twitter, still talks about me. He was one that said that the disco ball. Let me see if I can get that. I'll get this. This is the clip from Aaron Burrell. So this is the sort of stuff I was talking about, and to these people, Jesse Kozlowski. There was a guy called the Maine Surveyor. Doubtful that he's in Maine, or definitely doubtful that he's a surveyor because of the stuff that they've done. So, well, we can go over these individual bits. Let me just find this. Right, so this is the sort of tweets that I used to get on. So this is a guy called Aaron Burrell. He's still on Twitter, I think. He still talks to the Flat Earth Society guys. He says, maybe this will finally help. What about a disco ball, Bev? Have you seen how they take a bunch of tiny little perfectly flat square mirrors to construct a ball/sphere? Think of each piece as a 1/4 mile square. So he was saying 1/4 quarter mile squares, flat squares. I don't know what happens after that quarter mile, but they're unable to say. So this is the quality of surveyor that obviously we were dealing with. And Jesse Kozlowski was one of these people. So yeah, we have to go over. This is a video that Jesse Kozlowski made with Soundly about the bridge. Now, this bridge is well, it's been hotly contested within the Earth shape debate. This is what we're going to go over is how not to imagine that you're a globe surveyor and what not to do. Somebody's on about me talking so slow. Sorry. Yeah, I'm not Witsit. I'll try and make it sure everybody understands what we're doing. So, what we're going to go over is a video with Jesse Kozlowski talking to Soundly. Now, you want to be picking out a few different things here, but it's mainly going to be what Jesse's saying. And I don't know if anybody understands the actual argument, but we can get to the actual argument and about the double drop and the hump. You know, after this, we just need to let you know that this is the quality of surveyor that the globe puts up against, right? Now, we're just saying that plane surveying techniques are on the plane, obviously, and these geodetic principles within surveying don't take place until after 300 kilometers squared. So that's the place that you're dealing with plane surveying. A local plane is 300 kilometers square. That's what that's what the principles we were always taught whenever we were dealing with it. You know, these you don't need to worry about curvature at all, because within 300 kilometers square, all horizontals are parallel, and that's the way you deal with it. So I was after trying to talk to Jesse Kozlowski, particularly about the test, really. But it came down to the understanding of level. And I've got here, you guys are on, let me sort this screen out. That's not right. That's right. Right, now this might be worth going over this. Let me just get rid of that. Right. So this is a short video that I made the first time I ever got a chance to talk to Jesse Kozlowski. Now, where was it that I got a chance to talk to Jesse Kozlowski's? At Jose JG's. Strange place to meet a globe surveyor hanging out with Sly Sparkane and Sean Hawkins. You know, the typical, usual. I think it's 200 or 100. It's like, say, 100 miles square. Whatever. It doesn't really make any difference. No project's ever going to be that big. You'll always start from the local benchmark anyway. So it's just a ridiculous amount. Don't worry about it. Well, we can go over that other time. So let me know whether you can hear this. This is the meeting that we had with Jesse Kozlowski. The last time well, the first and last time I ever got to talk to Jesse Kozlowski. He's not around anymore, so it's unlikely that these conversations will ever occur ever again. Well, here we go.
Your autistic child is psychological child abuse.
Like that water is level.
No, you teach your child that level is a horizontal plane, which is not true.
Yes.
And the implication of that is that you are teaching your child the earth is flat.
No.
Yes.
But to be
Right, so he thinks fight the flat earth. This is what fight the flat earth actually thinks about what you think, okay?
thing is
I'm saying personally, I believe the things that you teach your child, your autistic child.
So he's pointing out here that I have an autistic child. I think Fight the Flat Earth also has an autistic child. And listen to what I say.
Is psychological child abuse.
Psychological child abuse. What I teach my son is psychological child abuse, according to Fight the Flat Earth. Like that water is level. And I say what? That water is level? And he says...
No, you teach your child that level is a horizontal plane.
I teach my son that level is a horizontal plane. Well, we do have an auto level. Yes. And the auto level does establish a horizontal plane. He knows how to set it up on the azimuthal. So my son knows how to set up an auto level that establishes a horizontal plane. What does Fight the Flat Earth think that is?
Which is not true.
Yes.
And the implication of that is that you are teaching your child the earth is flat.
So by me teaching my son that an auto level establishes a horizontal plane, according to Fight the Flat Earth, that's flat Earth. Well, I've always said, no, it's not. So if anybody wants to know where they got it from that I'm a flat earther, it's because Fight the Flat Earth told me that I was psychologically abusing my child by letting him know how to set up an auto level. Simple.
So the conclusion here is, well, first, Fight the Flat Earth is not Jesse Kozlowski.
Mm-hmm.
Just to be clear, right? But also, the tool that before the say the new modern times technology, the tool that was most often used in recent times.
No, it's the tool that is used in
create a level
times.
Today.
Yeah, still used.
Yeah. Okay, great. Because unlike Fight the Flat Earth would probably admit, I'm not a surveyor, so I have no clue. But that tool that all these surveyors use to establish a level horizontal plane, they would also be teaching their children, if they happen to talk about what they do for a living, that the earth is flat.
Yeah.
Did I got that right?
Yeah. Any surveyor or any calibration center that you take your auto levels to make sure they get the certificate, they get calibrated to be horizontal, exactly like I've just said. All I've been saying is the things that occur in reality, but there's a group of people that get really pissed off with it. And that's these people.
And it is a level that establishes a horizontal.
Mm-hmm. Yeah,
level is horizontal. Okay. Thank you.
So when I came into this, right, the implications, like Fight the Flat Earth says, that if you know a level is a tool for establishing a horizontal plane, and you teach that to your child, by implication, Fight the Flat Earth, the convicted criminal, like Emma says, definitely, he's just been convicted of grievous assault. Violent assault. So he has said that if you teach this known fact about these tools that everybody uses in reality to your child, you are teaching Flat Earth, and by implication, teaching Flat Earth is psychologically abusing your child. So you are, in Fight the Flat Earth's mind, a child abuser. So that's where I'm coming into this arena from. I know that measuring these elevation changes make the Earth not flat. And like I said there to him, no, it doesn't mean that it's a flat Earth at all. But carry on.
No. Yes.
No.
But to be
Well, it's a question for Jesse. I just want to know, is the level a drop from the horizontal? A measurable drop from horizontal?
Let him dance.
There you go.
Yeah. Jesse, did you hear that question from Bev? Make sure you're unmuted, Jesse. When you join, is muted. Ask again. Try thinking here. Jesse, you should be listening.
Go ahead. Sorry, I was on mute and I just came back in.
Right, Jesse, you said the level is not horizontal. So is the level a measurable drop from the horizontal?
I did not say that the level is not horizontal.
Right, okay, so talk about contradictions. He starts off with, he didn't say that the level is not horizontal. In fact, the flat earth may be tempted to call him a flat earther for saying that. You never know. Let's see what he goes.
I said horizontal and level are coincident with each other at one point only. And
coincident means they're the same at one point only. Only at one point. And a point is that of which has no parts. So that's nowhere.
that's at the plumb line where the observer is.
Oh yeah, I heard
the
that.
level.
So,
the level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
So, you want to hear that again? The level surface drops down from the horizontal. Listen to it again.
Ask again. Try thinking here. Jesse, you should be listening.
Go ahead. Sorry, I was on mute and I just came back in.
Right. Listen to this again. Right, Jesse, you said the level is not horizontal. So is the level a measurable drop from the horizontal?
I did not say that the level is not horizontal. I said horizontal and level are coincident with each other at one point only. And that's at the plumb line where the observer is.
Oh yeah, I heard
the
that.
Level,
so
the level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
So level drops away from horizontal. That's what, what you're dealing with.
Yeah. But so first problem I had immediately listening to this, and I don't know that I've ever heard this before, so this is new for me. But he says the level surface. What does the surface have anything to do with the level that you establish using an auto level tool? Does the ground have anything to do? You tell me, Bev. You know more, obviously, about surveying than I do. Does the ground have anything to do with the horizontal/level that you set at a particular point using an auto level tool or a water level tool or any other tool for establishing a horizontal plane of reference? Because my understanding is that the ground, the surface, has absolutely zero to do with it. In fact, it's above the ground in every case, unless you happen to be Buster and you're in the mines, and then it's actually below ground.
Yeah. Well, you're referencing the level to the ground. You're measuring the height of the ground away from the level that you've established. So for him to say it drops away when a level is the tool that establishes a horizontal, I mean, it's one of these vacuous statements.
The surface.
Yeah.
Yeah, but the surface is what he's saying. What the subject is the surface.
Yeah.
If you go back and listen, the subject he's using there that he's predicating upon is the surface. Mm-hmm. So I would say that the surface could be dropping down, it could be rising up.
Well, yeah, he could. It does. The surface goes all over the place, but he
Yeah.
says to a standard 8 inches times the distance in miles squared. You know, that's a very familiar saying, isn't it? I mean, I know it's Robotham, but
Yeah.
you know, that's what Jesse Kozlowski said. He just sounds like he's parroting this Robotham number.
It sounds that way to me as well, and it makes no sense when the subject is the surface.
Yeah.
Unless he has a different definition of surface than the thing that anyone would call surface. If you're looking at being outside, setting up a tripod and an auto level tool, or even utilizing a water level tool, and then establishing a horizontal, the only surface that would be around would be the ground. No?
Well, yeah, that's what you would usually reference the level to. I mean, unless you were to have a water level. I mean, that's because mainly what you see, we were dealing with this Realising Euclid test, which was water levels. And these people, this group of people, seem to get confused between a water level and an auto level, thinking as though they're two separate things. You know, the levels are different somehow. And I think that's what he was talking about. He says, so he's talking about the water level. The surface of the water would drop away from the horizontal, I think. But I mean, not having anybody like Jesse Kozlowski here to be able to confirm what that's saying. I mean, because if the water drops away from horizontal, that means there's a slope to the water. But then they say the water has an equal elevation, which means the horizontal must rise in relation to the water to keep that relationship. And that's just crazy because there's no slope to a horizontal. They're already stuck in the middle of some sort of a contradiction. Which is why I was trying to talk to Jesse Kozlowski about this. And it's always been very difficult to be able to talk to people about this very thing. The water level is it's an impossible tool for the globe model. See, look, I mean, in the Discord, if you want to come into the Discord, Flat Earth Math has put a sloping horizontal. It's sloping upwards. And that's ridiculous. The horizontals don't slope. Everybody knows that. But on the globe model, this dogmatic globe model that Flat Earth Math's bringing out, it does.
There you go.
Yeah.
It does. It must.
So, I mean, let's go on with this, and we can then get into Jesse and his show of
how many times
measurable, right?
My question is, how many times? Oh, yeah, it's measurable. It was derived.
That's all I wanted to confirm. So that's all I wanted to know. It's measurable, because obviously we've got a test, and if you can measure the level dropping away from horizontal, like measure it, then I mean, that'll be it. Game over. Bish, bash, bosh. Just show it. Jesse Kozlowski is the man. It's measurable. Listen to that again.
Distance in miles squared. How many times?
Measurable, right?
My question is, how many times? Oh, yeah, it's measurable.
Oh, yeah, it's measurable. Jesse Kozlowski says it's measurable. So if you want to know where Jesse Kozlowski is, he's not coming back. Because Jesse Kozlowski has said that the drop of level from horizontal is measurable. He won't be coming back because he can't measure it. He can't show you. He can't give you a method on how to do it. He's complete. This is Jesse's mistake, let's say. This is why Jesse had to disappear. It's measurable, Charles. flat Earth mathematics should be able to measure it. But I mean, they say it's unmeasurable. But that's why Jesse can't come back, because he said it is measurable. Once more, just so you know, you've heard Jesse Kozlowski say that the drop of the water level is measurable, right?
My question is, how many times? Oh, yeah, it's measurable. It was derived.
That's all I wanted to confirm.
You can measure this. Have you tried measuring this?
Yeah. So have you tried measuring this? Says Jesse Kozlowski. To the people who have actually done the Realising Euclid test. So I guess you could sort of say that measurement of 0. Yeah. Yeah, we've measured it and found out that level does not drop from horizontal. But hey, don't worry about that. We're going over what Jesse Kozlowski can do and how it's measurable on their side. Nobody needs to know how it's measurable on our side. We've said that there is no measurement because level is horizontal. That's the statement. Also to do with plane surveying. Confirms that sort of stuff. So the measurement is on Jesse Kozlowski's side. So if anybody's aware, Jesse Kozlowski's the man that's claimed that the drop of level from horizontal is measurable. That's the positive claim. There is a measurable distance between the two. Just measure it. It's easy. You're saying that a water level drops away from the actual level. You know, when you set up an auto level.
No, I didn't say
they're
that.
different, aren't they?
No, not really.
This is George, God rest his soul, coming in to save Jesse Kozlowski. That's strange, isn't it? How many times have you ever heard this happening? Jesse Kozlowski, the big man surveyor, being helped by George on
who's not a
Jose.
surveyor, right?
Yeah.
George was an engineer, as far as I know. Yeah.
Yeah, definitely not a surveyor. Yes.
Interesting that he has to come in White Knight for Jesse here. I wonder why.
Yeah.
An auto level.
George, I was asking Jesse, what are you doing?
An auto level.
You're speaking for Jesse, George.
I can't join in. You can't either, man.
George, let me talk to this man.
It's Brian Leakey there in the background as well.
Man.
Go ahead, Jesse.
Thanks. Okay, so how many more times must I explain this to you? I've explained this to you on Twitter, on YouTube, and now we're here in person finally talking to each other.
Yeah. He says he's explained it on Twitter and YouTube. You know what that is, don't you? Text chat. And how do you explain level dropping from horizontal? How do you say that you've measured it by explaining it in text? Don't think it's possible to do that, is it? You can't explain things in text. You need to be able to show people the method that they can measure this drop of level from horizontal. Well,
how many more times?
You're saying that level drops from the horizontal. A level is a tool that establishes a horizontal.
My question to you is, this is my question. How many more times do you want me to repeat this same answer?
One straight answer. Give him a straight answer.
All right, Brian, I'm gonna have to lose you from the call. Only Try Thinking and Jesse Kozlowski are the only two persons should be heard right now.
So that's my question to you, is how many more times do you want me to repeat the identical answer I've been giving you? I don't know. Is this months now since you started following me on Twitter? And
okay, well, can I go over it then and tell you what I understand, and you can just confirm or deny it, right? Just to make sure. You're saying that you can set up a level.
No, I just asked you a question.
See, this is how it gets. They always try and stall for time. He was helping, somebody was going to help him out here.
I'm asking you this. How many more times are you going to ask
just this
me
one? Just this one, Jesse.
So
Remember, this is the first time I've ever actually managed to get to talk to Jesse Kozlowski. And I came into this arena specifically to talk to this guy. This guy was my main focus. He's the only globe surveyor to say any of this stupid shit. The only. And there will never be anybody else like Jesse Kozlowski to be able to come into this arena. We're protected now. We're just with geometric principles and obvious logic. Jesse Kozlowski was getting away with this shit before I came around here. Now he's gone. You make it sure and let everybody know that you have definitely answered the question that I've asked, then that'll be the last time, Jesse. Promise.
So this is it. Drum roll. This is it, right, Brian? What's your name?
Do you know the question? Do you want me to repeat the question again?
Yes, you're going to, but I wanted you to answer me that one question. How many more times? You're saying this is it.
Right, yeah. Look at the elation in his voice, right? Knowing that this one time, this is all he'll have to do. Just answer this question. Just the first time and the last time. Everybody likes to say that Jesse Kozlowski left the arena because he'd had enough of me. And this is the only one time. Once. Yeah, if you answer the question this time properly and not obfuscate it.
Have you seen my answers before?
You've never really answered the question. That's why I keep having to ask to clarify, Jesse.
All right, let's try it.
Okay. Do you want me to give you the question then from full?
Yeah, let's pretend it's the first time.
Okay. I'm at the side of a canal and I have set up an auto level, right? That is establishing a horizontal line of view, right? Through the crosshairs.
Correct.
Right. And now I am at the side of a canal. Now that canal is water level. It is horizontal too, I say, but you say it drops away. Now, can you measure that drop of the water level away from the horizontal level of your auto level?
Perfect. Let's try to, Jesse, address you without interruptions. Go ahead, Jesse.
Yes.
That's it. Do you want to hear it again? Because this is Jesse Kozlowski, the last time, first and last time he ever got to talk to me about what he does. And I simply asked him, setting up an auto level at the side of the canal, the water in the canal goes away. Does it drop? Pretty well-formed question, that. Do you not think? I thought did all right. Let me ask it again.
Correct.
Right, and now I am at the side of a canal. Now that canal is water level. It is horizontal too, I say, but you say it drops away. Now, can you measure that drop of the water level away from the horizontal level of your auto level?
Perfect. Let's try to, Jesse, address you without interruptions. Go ahead, Jesse.
Yes.
Okay. Everyone's aware of that? Jesse Kozlowski states that you can measure the drop of a water level with an auto level. That's a measurable change on the vertical, which means an elevation change. The water level has an elevation change. That's a contradiction. Is it any wonder Jesse Kozlowski is not going to come back here? And you will never find any other surveyors. You will literally only get people like Flat Earth Math, George had a go. Who else? Sean G pretends to be a surveyor. There's a guy on Twitter called Aaron Burrell. There's people now that have decided that surveyors aren't scientists. So they can't do this. Not surveyors. But you've just heard Jesse Kozlowski, the last great globe surveyor. That's it. Saying that you can measure this. All I've got to do is just measure it. Simple. Don't be asking flat earthers to measure it. That's ridiculous. Don't be asking plain surveyors to measure it for you. They'll tell you that's fucking ridiculous. You guys should follow Jesse Kozlowski. Get Jesse Kozlowski to tell you the method to do that. Here we go again. Let's see what he says from here on in. Right. Of the water level away from the horizontal level of your auto level.
Perfect. Let's try to, Jesse, address you without interruptions. Go ahead, Jesse.
Yes.
That's pretty clear.
Can you do it without using perspective?
Why not? Why not refer
Whoa.
to
I don't think that was that it. Was that it? I heard Brian, I heard George, but it was supposed to be Jesse and Bev, like sorting this out and sealing it up for the last time. So let's give him an extra minute.
So you say it can be measured. What sort of distance can it be measured at, please?
What distance would you like to try to measure it at?
I don't know. I'm asking you, what distance can you measure it at? All of these people around here are thinking you can do it. So tell these people at what distance you can measure the drop of the water level from the auto level, please.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. George, let me talk to this man.
Yeah, that's it. He never answered. That's the end of it. So, Jesse Kozlowski, this is after, right? He did the Soundly stuff before this. So this was the last time Jesse Kozlowski was ever caught in public, because obviously you can't have people having to answer questions like that. How can he show that? Show a measurable change in elevation of the water level. Because an auto level's the tool that you use to measure elevation changes. And Jesse just said that the water level has an elevation change. It can be measured.
At 8 inches times the mile
squared.
Yeah. So if you have the mile, it's a half a mile. And then if you have the half a mile, that's a quarter mile. And if you have that again, it's an eighth of a mile. So he can measure all of those because it still works out to be 8 inches per the mile squared. Yeah.
The water level.
Yeah.
Yeah.
He should be able to, right? At very short distances, like, I don't know, 200 meters?
200, 400, 600 meters.
Sure.
It's claimed that, float tanks, other people have since claimed all sorts of different things. The Jesse Kozlowski, we're going to go over the bridge thing, which is a lot bigger, right? But it's still physical, still in reality, and still he's claiming to measure it. But you remember that Jesse's claimed that the water level drops from horizontal. This is one of the big contradictions. Because you'll notice the contradiction of the double nutsack drop.
Yeah. I didn't hear any measuring, though. To your point earlier, right? That you said there was no process there of measurement.
Yeah.
And you asked him, at what distance can you do the measurement? There's still no measurement. So when people say, measure, perhaps they don't really mean measure. I don't know. Measure to me means something specific.
Well, it's like now it's a claimed measurement from a globe surveyor, right? This guy's not a claim to be a plane surveyor. He's not a claim to be any other sort of surveyor other than a globe surveyor that has claimed he can measure the drop of water level from a horizontal surface established by an auto level. I mean, I know the surveying I did was plane surveying, but I mean, that's local. Everybody's a plane surveyor. All surveyors, whenever they're surveying plane surveying locally. That's what they do. You can ask him. That's why Jesse Kozlowski's never coming back. But here we go. Alright, so this is Soundly. Yeah, you guys have never seen these people. This is Soundly. Now Soundly claimed, I mean, we've had conversations with them, but Soundly's claimed to have been at this bridge for 3.5 years doing a study of this bridge, taking pictures and doing all sorts of stuff for the globe, right? That's how committed Soundly was to this. So here we go.
Are live at the moment. Today we have Jesse Kozlowski. We're going to be going over the drive that he did, collecting a bunch of waypoints across the Lake Pontchartrain Causeway. If you are a new subscriber, which I have a bunch, this channel does take a lot of photography dealing with showing the curvature of the Earth. And I interview people on a regular basis. Today's not really an interview. Today is more of a recap of a project that me and Jesse were involved in. There were some other guys as well, Mike, the Globetard, and James, Dandy Panty. He was also there. And so we are going to be going over Jesse's results. So as I have a new corkboard, and I'm adding items to my corkboard as I interview people, I'll go ahead and consider this an interview, Jesse, and throw your item up there. Beautiful picture of Little Tensas Bayou. Really appreciate that.
Get to that.
And Jesse, thanks for joining me, man.
Absolutely. Good to be on your channel, Soundly. Actually, I guess I can call you Lance now.
Yeah, you can call me Lance or Soundly, either way.
Just Soundly comes natural. That's how I've always known you. So
that's fine.
So yeah.
See now, how committed is that? Can you see Jesse Kozlowski's room there? Is there enough? Is there enough globe for you, or would you like a little bit more? I noticed there's a little bit of space up here on the back wall. He could have something up there on the wall, maybe. But
blue marble would be nice. Nice blue marble.
He's got a globe here, sort of grade, sort of, you know, he's gone for that colour. And then there's another map over here, and then he's got a big, like, curtain map. Maybe a map shirt. You know. Committed.
I figured it's about time we show some of the results.
I'm looking forward to this, man.
It's yeah, so collecting the data was easy. The harder part is putting it in.
Right, so the way I see this, so I can give you guys a setup, right? Soundly is the useful idiot. Now he's enthusiastic. He's good for the camera, and he's hip with the kids, right? Soundly's a good young lad, and he's sort of he's pushing it. He's enthusiastic. Jesse is the wizard in all of this. He has to watch his words, and he's very clever with what he says. This is the first part that I noticed. Let's get that a little bit bigger. Watch him.
Yes, man.
It's yeah. So collecting the data was easy.
Listen to the way he answers.
You can call me Lance or Sally. Either way.
Just soundly comes natural. That's how I've always known you. So
that's fine.
Hypercritical.
So yeah, figured it's about time we show some of the results.
I'm looking forward to this, man.
It's yeah. So collecting the data was easy.
It's yeah. Soundly says he's looking forward to it. I don't think Jesse is really. Jesse's
easy. The harder part is putting it into a presentation and to a visual form. And I just got an email from Walter Bislin 4 minutes before we went live, and he's really made. I'm going to turn off my phone. It's I've got the YouTube going on the phone. Okay, so he's made a lot of enhancements to his blog, and especially using this data. So I'll be showing that at the end.
Yeah, I've actually been putting off showing people this this new tool that he's provided because you wanted to show it today for the first time.
Right. So you should also be made aware of the fact that these guys are pushing a narrative. They're pushing a calculator. Walter Bislin, you might have seen him handing out super chats and stuff. He's the guy that designs models. Even more so. I thought this guy was the guy, but it turns out Stingray is a model guy also. So these are the guys that make computer models of things and sort of digitize them. Sort of what they do. Walter Bislin's done it. Jesse's pushing Walter Bislin, and so Soundly as well. They're all working together.
Yeah. So I'm really happy to kind of get it out there so that other people can start taking advantage of it, because he did make a general tool which lets people upload their own data. So this is going to be very interesting.
Yeah.
It's not. You can't upload your own data. You can't do it. Nobody can manufacture something that doesn't exist. So nicely pushed, but Soundly thinks it's real. Jesse obviously knows it's not.
So I've got a presentation put together. I guess, let's see, do I need to share my screen, or you're already seeing my screen? Let me know.
I see your video, but yeah, you need to share your screen. Yeah.
Okay, let me do that.
And I just as a side note here, I think that we were able to get a good audio setup here. If that's not the case, please let me know in the chat. I will check that out.
Yeah, let us know. We had different volume settings. I was loud and you were kind of soft.
Yeah, I think it's good now, but I mean, based on looking at it,
GPS
the feed, it looks good.
With,
okay. Well, look, I'll get this thing started. It's really the first presentation that I'm calling the GNSS survey of the Lake Pontchartrain Causeway. And there's going to be a bit of a tutorial on the spatial reference system that GPS and GNSS operates within. And I've already done a little bit of this, but I'm going to pare it down and go through some of it again. This whole thing about the ECEF coordinate system, the Earth-centered, Earth-fixed Cartesian coordinate system.
That's easy.
So let's do that. Before we get into that, I'll just make mention of what kind of motivates me to stay involved with this whole flat Earth thing.
Right, so listen to what Jesse Kozlowski says here. And this is for people that are sort of curious about flat Earth, right? And whether it's worth actually researching it or not. Listen to what Jesse Kozlowski says about this.
I I guess, found out about flat Earth about in 2015. And then once I was in, looking at some of this, I made a video called Geodetic Surveyor Straightens Out the Flat Earth, naively thinking, well, that, they just obviously hadn't heard of geodesy, and that'll take care of flat Earth. So instantly after that, videos were coming out about geodesy, and geodetic surveying proves the flat Earth. And over here on the left, we see different surveyors.
Sounds weird, that, doesn't it? Like after I came up with the argument that the Earth's not flat, and then that's what Flatsoid and Nathan Oakley said, that's what they're going to use for their proof of a flat Earth. Pretty much exactly the same as what Jesse is going through here, right? No difference.
Claiming that they never compute curvature in their work. And, that's good enough for a flat earther to just say, well, that means the Earth is flat. Well, it really just means that surveyor does not compute curvature in his work. And there's a lot of surveyors who don't. I mean, they just do what's called plain surveying because they just do a short extent of a survey. Or if they are working on long projects, highway projects and other projects, and they're not doing the calculations, that just means someone else is. So
somebody else is doing calculations.
So I do what I can to try to help people see this and try to understand the differences here. So I'm just waiting for the next flat Earth survey or flat Earth video to come out, and it'll be
Can I bitch about his mic?
Flat Earth.
What's that?
Can I bitch about his microphone? The crackling and scratching, he's blowing it out. Like he's blowing into the microphone whenever he talks.
Yeah. Hey, Rob, let him continue to talk so he can blow it. Listen to him blow it. His mind is. Listen to him. Listen to him.
Jessica,
don't white knight for Jesse Kozlowski, bro. Come on, bro.
There's no.
He's saying it like how surveyors get called flat earthers.
I'm not sticking up for Jesse Kozlowski, by the way. I'm just saying, his mic is horrible.
I'm busting Rob. I know you're not. I know I'm busting your balls, bro. I'm just giving you shit.
All right.
So
whatever. Go back to work.
Yeah.
whatever we bring forward, that ends up being proof of flat Earth.
That is how they do it these days. Yes. Yeah.
So whatever you bring forward is proof of flat Earth, even when you say the Earth is not flat. Like we've said. Could be the same surveying things that Kozlowski's talking about. Because he was talking about water level dropping from an auto level, plane surveying, right? Wasn't that what Jesse was talking about?
They're busy spending their days explaining why their flat plane looks exactly like a globe every time we measure it and photograph it.
But it couldn't be curved, no. Mm-mm. So, yeah. So people know that I've tried my best to engage with Chris Van the Tree. Had some live hangouts with him early on, like a year ago, and then I tried again later, especially when I saw this video that he's...
Chris Van the Tree was part of FE Core, one of the Bob mates. I did get a chance to talk to him about the water level test. We were members of FE Core as well. I don't know whether I still am. I doubt it. But yeah, I don't know.
He's going to do this flat Earth survey, update 1. I haven't heard anything more about this, but Chris chose not to continue the discussions. I mean, it wasn't meant to be a debate. It was really meant to be a discussion. And the reason I'm bringing up Chris again here is simply that he's still involved in the flat Earth community, as far as I know. And I still think he works as a surveyor. And the point to this is this, that I'm going to make a presentation tonight that may interest him. And it would be interesting to find out what his take is on what I'm going to show tonight, since he has that
I think Chris Van Matra used to play footsie with Jesse Kozlowski. You know, them both being Flat Earth Society. They can both pretend that each other are, you know. I think they're all just actors, to be honest. I mean, there is no debate about surveying. They're just standard practices.
Level of expertise as someone working in the surveying business, and he uses GPS and made that known in our Hangouts, and he says it works quite well. So he uses it all the time, just like I do. And then further, just to understand that the things that I'm going to show you tonight are exactly what he would do if he could do exactly what I did. And it's simple. You're going to see I just mounted a GPS receiver on my car and drove across the causeway. So there was really nothing special to that. So he would collect the same data that I collected. So it's a matter of taking a look at this data and seeing what it tells us. And that's the last thing I'll say about this slide, is that we all have our opinions and we can all bring our own ideas about things, but really
this is just to show that
the proof is in the pudding. It's in the measurements. So I asked Chris to go ahead and do a very simple test. I think flat earthers who are looking up to him or looking at him as someone to give credence or credibility to flat Earth just should ask him, you know, like, yeah, what would happen?
Who gives credibility to flat Earth, and why does anybody imagine that somebody might be giving credibility to flat Earth? It's crazy.
Happen if you did that test? What would happen if you measured 1,000 feet? It wouldn't even take you a half an hour to do it. And the fact is that that all the GPS that he's doing is the same as what I'm going to show tonight. And the reason I'm going into this in some detail is because a lot of flat earthers are looking at what we did here at Lake Pontchartrain. So try to understand the importance of this. So
the flat earthers are looking at what Jesse Kozlowski did at Lake Pontchartrain. Do you reckon? Does anybody reckon that ever occurred? Or maybe one massive smoke screen went on, just obfuscated the shit out of it so nobody understood what the fuck was going on, maybe. But we'll try and cut through the fog of what Jesse Kozlowski and the wizardry he's doing. This is sort of a setup to say that, look, I've got a mate who me and him are playing together, but if you look, it's got flat Earth S. A flat Earth Society. That's all that is. Just it's on screen to let you know you're seeing it. FES. It's there on the screen.
There's no hocus pocus to this data, and we'll get into this a little bit more. So in a nutshell, the system that GNSS operates in, or is referenced to, is a three-dimensional Cartesian coordinate system. It's a rectangular coordinate system, and any point P can be described as having coordinates X, Y, and Z. And that's how it works. It isn't latitude and longitude. It's not elevations. It's Cartesian coordinates X, Y, and Z. Now,
whereas you would imagine the X and Y would be on a horizontal plane and the Z would be an elevation. But Jesse's just said it's not that, but it is. If it's not using the X, Y, and the Z as being a vertical, then what is it? Why isn't it that? Ask yourself that and see how well you can do straying away from that. This is just Cartesian, as you'd imagine. XY plane, elevation measured on the Z axis.
Once you have those coordinates, you can do things with them, such as convert them to latitude and longitude and ellipsoid height. Keep in mind, this is a three-dimensional system. So it's not only latitude and longitude, it's latitude, longitude, and ellipsoid height, height above or below the ellipsoid. But we don't have to do that. You can leave it right here, and you're going to find out that in the test that we're going to look at, these are the coordinates that we ended up using that reveals the shape of the bridge. So back to this. Customarily, what we normally would do with our survey data is not leave it in X, Y, and Z Cartesian, but to go ahead and convert it to latitude and longitude and ellipsoid height.
No, you don't convert it to latitude and longitude. There's not much point in doing that. Well, maybe Jesse does, because that may help within this idea of saying to soundly. But, I mean, hey, Jesse Kozlowski's not going to be around here, so he can't really explain to us what he was talking about. Although there will be people like Flat Earth Math that wants to speak for Jesse, but they won't be able to, because they won't be able to translate what Jesse's talking about either. Wizardry.
And once we do that, and here's the math for that. This was included in the other video I did. Just converting, you can go from latitude, longitude, and ellipsoid height to XYZ, or XYZ to lat, long, and height. And once you do that, you're able to develop elevations. Okay, so you're going to take...
Can you see that on the screen? There's never been such fucking stupid stuff. But all of these here, they've got right angles on this bendy line here. And it says plumb line, pointing to this bendy one over here. Looks like a rumpus pole. That's I think that's what Rumpus was trying to emulate when we were going over that. Deflection of the vertical. Nice.
The heights that are referenced to the ellipsoid, and you're going to apply a geoid model to arrive at elevations, and that is what we normally would be doing in day-to-day survey work.
Normally.
And it would look like this after you've converted to latitude and longitude. You're going to planarize that.
Plane it.
Because ideally you want to be working in a very simple system, simple trig, simple geometry, X, Y coordinates.
So you've measured locally with a plane surveying tools, and now you've made it into a plane. I mean, that makes sense, doesn't it? Like, that's what you end up with once you've done surveying with plane surveying. That other bit was just a wizardry in between.
And, nobody really works with latitudes and longitudes when they're doing house stakeouts or construction stakeout or property surveys. We're generally planarizing a small portion of the earth, which could be a whole state or a county or even a little neighborhood. So what you're going to end up with are XY coordinates, and we can make use of these types of geometric arrangements, either using an intersecting cone.
This is a little bit of mathematical trickery again. There's no point. He's just got it as a plane. He's used plane surveying tools to measure stuff, and then he's got it on a plane. I don't know what all of this is for. Just wizardry. Forget you even seen it.
Or cylinder to develop these northing eastings or YX coordinates. And that's what the United States state plane system is built on, and also the worldwide system used, which is called Universal Transverse Mercator, UTM, and certainly all the countries in the world have their own localized projections for their countries. So here's an example.
So it's just to let everybody know, like we all have maps, and all of the coordinates are plotted on a plane, the paper for the map with grid coordinates. That's how you know you're dealing with a plane surface, and that's what Jesse's talking about there.
Showing you this data that was collected on the causeway. This is in Louisiana, South Zone, state plane coordinates on the North American datum of 1983, adjustment 2011.
So it's state plane coordinates, right? Definitely. That's what he said.
And here we have the northing and eastings, and here are the elevations. And you're going to find out that this causeway is very level. They built the thing to be level, except for the marine spans and the humps where, you know, boats go underneath of. Otherwise, this thing is level. And you're going to
level.
See that.
Level.
Here's an output of a comma delimited file just from Excel with the point ID, northing, easting, and the elevations, and just a description of the road surface.
They're called northings and eastings because north, south, east, and west are perpendicular to each other, forming a grid. And those grids make up the grid coordinates on the state plane coordinate system. That's what he's talking about. Now, whenever he talks about elevation, he's talking about elevation points on reference to that plane, the state plane coordinate system.
And you can see these points are approximately collected about every 10 meters or so. And you can see how level they are. And this is in meters.
It's about 33 feet. Every 33 feet.
So we would take these types, you know, normally, what we would normally do in surveying is to take these coordinates and put them on a map. Here's a USGS 7.5 minute topographic quadrangle map. Here's Mandeville. And the coordinates on the side are latitude and longitude, but also UTM and also Louisiana state plane coordinates. They are here too. And what I've done here is just taken that topographic map into my global mapper program and plotted the points collected as northing easting values on this map. So
what he's done is he's got GPS coordinates and he just plots the points on the map. And then the system already has a digitized map. And the elevations will come from that. Of the points that are already measured, the elevations reference to the state plane coordinate system.
That's your, you know, normal use of GPS and surveying, is to create a map for some purpose, whether it's for design, for engineering design, or a property survey or something like that. This is how we would normally proceed. And here's another map of the same area, and this one is in UTM.
So they've already been done, right? These all of this stuff that Jesse's talking about has already been done on these maps. Everything's already been sorted. So what's Jesse doing? Well, he's doing a little bit of wizardry for Soundly here in this particular community.
Coordinates. So that is the normal way of doing business day to day as a surveyor. What we're going to do here is not planarize these, but leave them as X, Y, Z coordinates. And
it's already measured on the state plane though. So why is he not planarizing them? Using GPS. GPS is a plane surveying tool that plots points. I don't know why he said that. A little bit of wizardry again.
So we're going to basically be just dealing with the actual vectors themselves rather than projecting it to the ellipsoid or to the ground. We're going to be staying right in this Cartesian system. And here's what those coordinates look like. So we have the point ID, and we have the Earth center, Earth fixed X value, the Y value, and the Z. And is this coming across okay? Can you see it on the screen pretty good?
Elevations.
Soundly? You there?
Yeah.
Okay, good.
He's got elevations here all the way down. 5.7, 5.7, 5.7, 5.7. All the way.
Now, what I also did is I added the column E and I put the elevations there. The elevations have nothing to do with these XYZ coordinates. I just wanted them to be there as part of the display. So,
what do you mean they've got nothing to do with it? It's just put them in there, but they've got nothing to do with it, apart from being in column E. But really weird, the elevations, because that's what he's dealing with, elevations. That's exactly what he's talking about, isn't it? If the water level drops away from the horizontal, and the horizontal is where you measure elevation changes from, then that's got to be an elevation change. But there's no elevation change. It's all the same all the way across. Because you've got to remember how accurate his GPS is while he's driving in his car at 40 miles an hour or whatever they do.
So that when I create my graphic visuals, you'll be able to see what the elevation is of point SB. SB stands for southbound, point 42. That will be displayed. Also here, this column is indicating the precision at which this data was collected and processed. And
right, so here's what we're after. When we talk about precision, when we go out there to do surveying, we talk about within the 1 millimeter range. We're talking about first order accuracy, and if you're talking about elevation changes, you want to be within the millimeter to be precise. That's what we're dealing with when we go out there and deal with what we do. Jesse, obviously, he's driving over a bridge in a car, doing car surveying. It isn't really a surveying technique, but fancy Jesse. Soundly's going to go for it, but listen to the accuracy that they're dealing with.
Is that 0.02 meters?
Yes, 2 centimeters.
Wow.
Horizontal. 5 centimeters vertical.
2 centimeters horizontal. That's like within 2 centimeters on the horizontal grid. And he's saying 5 centimeters, within 5 centimeters vertically. The accuracy. Have a look at what's 5 centimeters? 2 inches? That's not a very good accuracy, is it?
And let's talk about that real quickly. These are at a 1 sigma. They're not at a high confidence. They're at a 68.3 confidence. That's your standard error of 1 sigma.
Gotcha.
So for higher assurance, you would multiply this by 1.96 to get 2 sigma, or you could say just 2. Just double these. So we're going to say that the vertical is good to about a decimeter.
Decimeter. That's 10 centimeters. 4 inches. That's the accuracy that Jesse's talking about for his vertical. When we talk about a millimeter. This guy's talking about 100 times that. Jesse Kozlowski. He said it's measurable, a water level, measurable from the horizontal. Yet he's talking about 10 centimeters error. Mental. You got away with it.
Which is what, about 3-4 inches,
so
right?
within 10 centimeters.
Yeah.
Yeah.
That's fine. Yeah, I mean,
So
that's
what-
still
so
really
it's-
good.
That's still really good, says Soundly. That's fine. Yeah, it's still really good. Really good. It's not. It's shit. It's like, it's worse than shit. It's fucking awful. But Soundly's like, yeah, well, whatever. Go with that.
Yeah, it's like 4 inches or something, right?
Yeah.
Right.
And I mean, I'm just doubling it up just
Double it,
for
Harry,
to be
double it.
conservative about it.
Right.
So
I mean, you could
and you'll see
quadruple it
them
if you wanted to.
rise up and down as you look through the file. So basically, there's the file that we're going to be using for the graphics here. Now, here's an example of just
Right now, and this is for anybody that says, well, Bev put research flat Earth on his surveying when he had his land surveying certificate that the Globers keep wanting to push out there, where Bev obviously had his research flat Earth. I mean, look at this, Jesse Kozlowski. Do you think that was actually up there on the billboard, or do you reckon Jesse Kozlowski's put that on the billboard? What do you reckon? Which way round was it? Jesse Kozlowski got research flat Earth put up on a billboard so he could use it. Right, now please listen to this that Jesse Kozlowski is going to say to Soundly. Right? Take note of this.
Surveying something. You take this billboard, and if we were to survey the corners of these letters, we'd be able to draw lines between those. And if we surveyed the corners of the billboard, we'd be able to determine the shape of that billboard. And this would have nothing to do with whether I'm...
He wants you to look at that billboard. He's got big pink lines on it. He's gone and framed it. Certain letters. He wants you to focus on that billboard. This is Jesse Kozlowski.
Straight onto it or skewed to it. You know, what I'm getting at here is this whole idea about perspective does not affect the actual physical location of where these corners are. The dimensions are going to be the actual dimensions no matter what the visual looks like. So keep that in mind as we start to look at some of this data and some of Soundly's pictures, because people are just really struggling with what is obvious. So,
right. Do you want me to go over that again? Did you get a grip on what he was saying there? Go back over it again, because I think this is pretty important, right?
Here's an example of just surveying something. You take this billboard, and if we were to survey the corners of these letters, we'd be able to draw lines between those. And if we surveyed the corners of the billboard, we'd be able to determine the shape of that billboard. And this would have nothing to do with whether I'm straight onto it or skewed to it. You know, what I'm getting at here is this whole idea about perspective does not affect the actual physical location of where these corners are. The dimensions are going to be the actual dimensions no matter what the visual looks like. So keep that in mind as we start to look at some of this data and some of Soundly's pictures, because people are just really struggling with what is obvious. So,
okay, you want to recap? If you survey anything anywhere, then it doesn't matter how far you go away from it and what it looks like through optics or anything. You will not affect the actual surveying of whatever it is you're looking at. And he said that blatantly to Soundly right at the beginning. Soundly's the guy that took the pictures. He says, doesn't matter what you picture, Soundly. This building is going to have been surveyed when they built it, and it doesn't matter what you what you do when you look at it. Part of the big trick. This is how wizards work.
So here's a small test I did on the 6th of January, and that was a Sunday, and this is on Little Tinsus Bayou. I went back there. This is a year later, and I measured the reciprocal zenith angles across that. It's about a 6-mile stretch.
Jesse, the re-emergence of the reciprocal zenith angles. It's Jesse Kozlowski that put this to effect. So take it on. What's he saying about it? This is where you'll be going. Can you go and check what's going on with Erdbear? What the seems like the bots are acting up. Go and see what it is. I don't know how many duplicated text it can be.
Something like that. On the plane ride home, I did some calculations, and this is kind of rough here, but
this is actually quite good, right? So let's go back. This is Jesse Kozlowski, straight from telling soundly that it doesn't matter what you've done once you've surveyed it. You're not going to change what you're looking at.
So here's a small test I did on the 6th of January, and that was a Sunday, and this is on Little Tinsis Bayou. I went back there. This is a year later, and I measured the reciprocal zenith angles across that. It's about a 6-mile stretch, something like that. On
6 miles, around about the same as Bedford, 6 miles, canal. So maybe, I don't know if anybody's around there, Little Tinsis Bayou, see whether it's got bridges on it that you can see from one point to the other. You might be able to do the reciprocal rumpus pole test.
On the plane ride home, I did some calculations, and this is kind of rough here, but I'm throwing it in because this is going to be one of these launching points to do another video or a presentation on these results.
Reciprocal zenith angles. This is where he first put it out. This is where you heard it first. First public showing of reciprocal zenith angles from Jesse Kozlowski.
But I just took the XYZ coordinates of the tops and the bottoms to determine the tilt between them, because obviously the plumb lines are inclined outward, away from each other.
Plumb line tilt. Jesse Kozlowski calculating on the plane ride home.
And that came out to be 5 minutes, 50 seconds of inclination. And what I measured was 5 minutes, just roughly 5 minutes, 40 seconds.
Equipotential angle of adjustment. Welcome. Thank you very much, Jesse Kozlowski. We'll go over that again. But Jesse Kozlowski measuring the equipotential angle of adjustment, the tilt of the plumb bobs.
Let's round that off. Those are the adjusted angles.
So you're saying that your measurement over Little Tinsis Bayou was correct within 12 seconds?
I wouldn't.
Of the predicted value.
Well,
no, I didn't. I haven't even calculated what the prediction is.
Okay.
He hasn't even calculated what the prediction is or his errors. He's not calculated his errors yet or anything like that. Don't worry about it. He's just trying to show off soundly. You're not meant to be asking those sort of questions.
And again, I haven't even looked at this thoroughly. I'm just showing you that, hey, I measured zenith angles. That was the tilt I determined there. And then using the
Plumb bob tilt again. He's brave, isn't he? Just sort of like straight there. I'm not saying anything, but I'm just saying that I did some surveying and tilt.
GPS, I'm finding very good agreement. I would not say, oh, it's good to 12 seconds or something.
Okay.
But if we want, we could round off to minutes. Let's say there's going to be a plus or minus value in the seconds column, but certainly we would say. The minutes are good.
Right.
6 minutes, let's say. Let's round it off to 6 minutes. Almost 6 minutes. Maybe not. Maybe 5 to 6 minutes. Okay, right. Something like that.
Yeah, something like that.
So there's that. So this see where this is going, and now that's a simple test. Obviously, now we're going to look at a very long bridge. I also want to make the point that.
Oh, here we go. So he's just He's like it's bombardment for Soundly. He doesn't really understand what's going on at the minute. But Jesse's just said plumb line tilt. He's just calculated it on the plane ride home. But you're going to find out where it comes from here now.
There's so much controversy about how GPS works, how it, like Chris Van Matray had made it clear that he uses GPS, but he doesn't believe in satellites, and it's all based on cell towers and so forth. But whatever the case is, I mean, whatever you want to believe about that, the fact is that highways are being built using GPS. Here's a road grader with GPS mounted, controlling that blade and controlling the alignment of where they're building this road. Same thing for these bulldozers. This is called machine control construction now, and you're going to see this all the time. This is what's happening. Whether it's cell towers or satellites, this is working. So it ought to have worked for what we did.
Yeah, I'd like to just reiterate that before you go further. Is that we've had a number of flat earthers, even the world famous Beeloo video where they were using GPS. So GPS is definitely
the world famous Beeloo video. Anyone know Beeloo? I didn't know what Beeloo was until I think it was Clary pointed out. The world famous Beeloo is an alien. I think it was a Spanish group of people, but they had an alien called Beeloo.
Something that they have agreed works. They just disagree how it works. So
I'm glad you brought up Beeloo, because I have to give credit where credit's due. This whole tilt thing here that I've been doing this past year, I got the idea from Beeloo. I'm not kidding.
There you go. Jesse Kozlowski has got the idea of looking for the tilting plumb bobs from Beeloo the alien. And again, listen to that again. It's amazing. Jesse Kozlowski, ladies and gentlemen.
This is working. So it ought to have worked for what we did.
Yeah, I'd like to just reiterate that before you go further. Is that we've had a number of flat earthers, even the world famous Beeloo video where they were using GPS. So GPS is definitely something that they have agreed works. They just disagree how it works. So
I'm glad you brought up Beeloo, because I have to give credit where credit's due. This whole tilt thing here that I've been doing this past year, I got the idea from Beeloo. I'm not kidding.
He's not kidding. He did. He got the idea of tilting plumb bobs from an alien. He's been doing calculations on the plane rides home and doing all sorts of stuff. He sees tilting plumb bobs everywhere, does Jesse Kozlowski.
That actually makes sense, though, to me.
Yeah.
I mean,
yeah, he's mad.
Seriously, I'm not kidding.
He's crazy.
That's where I got the idea of tilting plumb bobs from an alien. What? Yeah.
It sounds like, well, yeah.
Amen to that, brother.
Yeah.
Shit.
I mean, where else? Who else would tell you about tilting plumb bobs?
Yeah, right.
Sounding like not surprised.
Soundly, you and I were out there in Minnesota at George's. And that's
God rest his soul. So Soundly and Jesse were out at George Nutsack's. Anyone else there? Here we go.
In Minnesota at George's. And that's about when that Beeloo video came out.
Right.
And those scientists were talking about the tilts of buildings and using GPS to determine that. So
he was at Rainy Lake with Soundly and George and got the idea of tilting plumb bobs from Alien.
That's where I got the idea. I'm not kidding. And it works, by the way. It does work.
Talk about shooting yourself in the foot, huh?
I've computed the tilt.
He's not. See, he's not kidding. Who's that? We've got. This is a YouTube guy. Welcome. He's very defensive for the globe surveyors. It's noticed. It's good to know who are the people that are coming out here to defend Jesse Kozlowski, because obviously Jesse Kozlowski's not going to come back. How's the poll doing? We're doing all right. Is he believed that he's going to be coming back? Do people know who he is? So he's calculated. We'll get this again. Did you think about your surveying god, Jesse Kozlowski, being taught to look for tilting plumb bobs by an alien?
Between the Washington Monument and the Empire State Building, the Washington Monument and the Sears Tower in Chicago. I mean, nice. I've never made a video of that, but that would be another cool little, thing to look at and make.
Right. So what he's talking about here is after Belu, the alien, told him to look for tilting plumb bobs. He's talking here about how he's computed. So listen to what he's computed. I don't know if anybody else has computed so many tilting plumb bobs as this, but I mean, listen.
I'm not kidding, and it works. By the way, it does work.
Talk about shooting yourself in the foot, huh?
Right.
I've computed the tilt between the Washington Monument and the Empire State Building, the Washington Monument and the Sears Tower in Chicago. I mean, nice. I've never made a video of that, but that would be another cool little thing to look at and make some graphics. I really need somebody to do animation because, the measurements are easy to make, honestly.
If anybody's out there and knows how to graphically represent tilting plumb bobs without making it look fucking ridiculous, let us know, because Jesse needs some help. I wouldn't mind knowing how we might be able to graphically present tilting plumb bobs. I'm interested. If anybody knows, if anybody's heard anything from Jesse Kozlowski about this person who can do graphics for him, let us know.
Okay, so we can establish that GPS does in fact work. Yeah. Regardless of how it works, it does work.
Yeah. Well, here's a graphic that...
There we go. We've just sorted that out. GPS works. Doesn't matter how it works. It just works. Right? So now we've got that sorted.
Tells us how it works. Whether you want to believe it or not, the fact is that it's used in agriculture a lot now, and people spend the money to put these systems on to guide these tractors. It increases their yields.
Didn't it sound like a wizard trick now, right? Because before GPS was done, they needed maps already there to plot the GPS points on. So those maps were already made. It was already done. This is just a little glitter and fancy stuff. He's putting a bow on the top of it when it's all the work's already been done by people who didn't use GPS.
They can run through these fields within 6 inches of each pass. It's a big deal. And so there's a lot of manufacturers building these systems. So let's all agree it works. We're using it. So that's the point I'm making in this build up to looking at the
point he's making is that they use GPS and it works. Yes. I think we can all do that. I don't think they have tilting plumb bobs. I don't think they've had any words from aliens yet, but you never know.
Causeway data. Oh, and let's not forget, it's used in surveying a lot. Here's a guy doing some construction staking. They're about to pour concrete here. This could be a highway. It could be a bridge deck. I don't really know, but there he is using GPS. Here's a bridge, and they're monitoring the bridge using high precision GPS here, and here's another shot of some GPS equipment on this bridge. So it's used for monitoring bridges to high precision, and certainly to build these long bridges. So now let's get to the topic here tonight, the Lake Pontchartrain Causeway. I want to make mention that this thing was built back in the 50s, and it was built using...
Right, this thing was built back in the 50s. Built using... that was before GPS. So the actual bridge was built before the GPS system that he's just been talking about. So that's completely irrelevant for what he's about to talk about.
Built back in the 50s, and it was built using old school surveying, transits, levels. Here is the triangulation. This was geodetic triangulation to establish control points out near the bridge, as they were using these as control marks to set out the piles and all of that. And of course, this old school methodology is still used today, except that it's not a manual transit, it's an electronic total station, but the same types of surveying activity takes place to build these large infrastructure projects.
So exactly the same as before they had GPS, they were using plain surveying tools, and the modern stuff that they use today uses the same methods, meaning they're plain surveying tools. All tools for surveyors use plain surveying tools. Jesse's just telling you that.
So what I'm showing you here are the control points that were established using, like I said, old school triangulation. I'm bringing this up because people lately have been saying, well, the instruments don't work, or you're looking too far, and all this. Well, these are the actual control points, and let's take a look at this particular one, number 1. Here's the data sheet on it. It's a first order triangulation station. That means its positional accuracy was determined to 1 part in 100,000.
That's to the 1 millimeter that we were talking about when we do it, first order measurements. That's what we were talking about, not what Jesse was talking about when he drove over the car and got 10 decimeters or whatever, a decimeter, 10 centimeters. That's not first order.
And that was back in 1953.
1953. So they were good.
The elevation, actually, they have some asterisks here, and they are talking about the subsidence. In the Louisiana area, in the New Orleans area, there's a lot of subsidence, and old published elevation values are no longer valid, so they didn't keep that elevation here, but you could go back and find the original, and you'd have the elevation there as well. So here's all this stuff about length and how far you should be able to see, or how far can you use these instruments and so forth. This one's about 7 miles from station 2 to 4. I'm just doing the inverse there. It's just around 38,000 feet. I'm rounding off. So there's an example. So they kept these close to the bridge. That was the purpose. I'll tell you what, if this bridge was not being built here, they would not have bothered to put these points here at all. They would have just measured right across the lake.
Right.
And from a higher tower or something like that, they would just build a 100-foot triangulation tower and observe really far, like some of these lines. Here's the rest of the triangulation going on. This is just the southeast corner of one particular map around Lake Pontchartrain. But if you really want to see some long lines, how about over here in California? Here's a little snippet of the California triangulation diagram. And here is Mount Diablo. These are very long lines, like 100-mile long lines. There's no
Wow, so none of them are 280 mile lines, like the surveyors of the main surveyor when he did his graphic that we went over the other day that Brenda used at Gerrans. None of them are quite like me. But these triangles here have to be, and I'll explain to you now. These are triangulation points. So they make triangles, and all of these triangles have 180 degrees. That's how they can do trigonometry to mark these positions. So all of these, when you add them all up, will add up to 360, because that's a circle. And these lines will form triangles at these points, and you'll be able to measure other points to triangulate every position on the map. All of the triangles, every one of them that you see there on the screen, will have 180 degrees, because triangles only have 180 degrees. Jesse's obviously talking about triangulation, so everybody knows triangulation uses triangles with 180 degrees.
Question about it. It isn't a question of, oh, can they see that far and should they have gone that far? Well, they did. They do, or they did. We use GPS now, but back in the day, these lines were observed, these angles were measured, and that is what produces the maps that we have today. So that's just how it works.
See, there you go. He's just confirmed. That's what makes the maps that we have today, is these triangulation methods. Now, these are angles on the azimuthal, on the horizontal plane. They're not elevation angles, just triangles within the horizontal plane on the azimuthal plane.
Right, and the triangulations from the other directions all mesh up.
Of course.
They're all self-consistent.
Yes.
Yeah.
In fact, and when you start to measure these very long lines, and when you form a triangle, you have what's called spherical excess. Because
I've never even heard that before. That's nice. It's interesting. Listen to this, Jesse Kozlowski.
You have what's called spherical excess, because these plumb lines are all away from each other, so you're actually going to be measuring a larger triangle. So if they account for a spherical...
Measuring a larger triangle because of the plumb lines? That sounds like some Stark Odders shit, that. It's on the horizontal plane. These angles are measured, so plumb bobs don't really come into it. Jesse Kozlowski sure he's... I'm not too sure, you know. Up to you. What do you think? What do plumb lines have to do with triangles measured or angles measured on the horizontal plane?
Maybe below said something. I don't know.
He said the triangles would be larger, didn't he? So we'll go again. This is great.
Be measuring a larger triangle.
Yeah, measuring a larger triangle. You can measure angles of a triangle. But how could you measure a larger triangle? I think that's great. Tell us again, Jesse.
Spherical excess, because these plumb lines are all away from each other, so you're actually going to be measuring a larger triangle. So if they account for a spherical excess, it's an actual measurable, thing.
Right.
It's an actual measurable, thing. And sounds like, yep. Useful idiot. Just nod. Yeah. No, Jesse. Triangles only have 180 degrees. In reality as well. You don't measure larger triangles. You measure the actual triangle. And he did just say that, all of the positions are what they are. And now they're doing this wizardry. Fancy.
Exists. But I've kind of taken a little bit of a side road, but it was necessary because I want to emphasize again.
This is worth listening to, just to make sure, to see whether you've been taken in by it or not.
Because these plumb lines are all away from each other, so you're actually going to be measuring a larger triangle. So you have to account for spherical excess. It's an actual measurable, thing.
Right.
It actually exists. But I've kind of taken a little bit of a side road, but it was necessary because I want to emphasize again that the causeway. Let me back up before I talk about Mount Everest. The causeway was built using these old school methods, and here today,
they didn't have triangles with more than 180 degrees. So why is he trying to tell Soundly that they do? Spherical excess. Wizardry.
In these day and age, we have done a GPS survey, so we're going to see how well these things match up. Okay, it's something to think about. And again, they built that thing level across that lake. It's an amazing piece of construction. So, and as far as the long lines go, certainly, here's a little map showing Mount Everest and all these Himalayan mountain peaks that were determined. The elevations are determined from geodetic triangulation.
Do you think they took up a theodolite or something to the top of Everest? Or all of those peaks? Teams of surveyors taking. I don't know.
Believe it or not.
Right, if somebody says that to you, believe it or not, and then laughs.
Yeah, the nervous laughter. It's the theme, isn't it? It's really weird.
It's like he's trying to... this is wizardry, right? What he's doing to Soundly, and it's see what you can get past Soundly and just say it. Because this is a normal narrative that he's just going over. But, I mean, how confident would you be if you heard this?
Believe it or not. So.
Like, not.
Yeah.
Definitely.
Not,
I'm not believing
not
that.
real confident.
Yeah.
Nope.
You're not confident about it. Neither am I now.
So let's get to
so all that to summarize, basically,
yes,
surveying works, triangulation works, and GPS works.
Yeah, I think it does.
Yeah.
So let's sum it up. It works, but not with triangles with more than 180 degrees because they don't exist. Hey ho.
Well, it's not that we think it does. It's that we have practical results that show it does.
Absolutely. I'm just...
Yeah, we do. We have practical results that show it does, and triangles do not have more than 180 degrees. Make of that what you will.
I'm just chuckling at some of the comments that I've seen, and so I don't know how serious to take some of it. So here is a video you can go watch over on Sally's channel. Sally was like at Command Central, up there in the room, doing the live streams, taking the long exposures, the video, and occasionally, us, wherever we were, I know Mike would be out wherever he was, wherever I was, we would kind of call in and get into a live stream. So you can watch this. This was Friday night, I think, doing that first pass on the northbound side.
Yeah, what I call the GPS waypoints.
Yes, that's right.
Where you're recording locations of the surface of the bridge.
That's correct. So here's a little preliminary setup, assuring that we knew what the antenna height was above the road surface. So we put this is a magnetic mount on the car. I just used a survey rod and a plumber's level. This level has a groove in it.
Can you see that? He's got one of the cheapest ass throwaway bubble levels you've ever seen. It wouldn't last 2 minutes on site at all. That's not what you'd call a bubble level. You might have one of those in your garage, but if you do, it's not a working tool. That. And he says it's a plumber's one because it's got a groove in it. A plumber's level. A plumber's level. And what's he doing? Right, he's measuring the height of this using this rod here by doing that and then measuring here. Neither of them are in the car, and they're not going on the road. There could be any sort of tilt going on. It's like whatever measurement they're going to get here is not going to be an accurate measurement for the height of this because they're going to get in the car. This is Mikey, I think. Mikey on the bayou. He's one of the biggest trolls as well. Shout out, Mikey, if you're listening.
So it just, sits right on top of that round surface. There's Mike holding it. Here we are measuring. Wanted to make sure everybody saw that, it was level. I'm sorry that Bob, the science guy, took so much heat because...
Yeah. He's sorry that Bob the science guy took some heat. Does anybody know why Bob the science guy took some heat? Not for the shorter than a straight line thing. I don't know. I don't know what it was.
The thing was his level was like a smidge out. So there's a picture of its level, and we're measuring to the nearest millimeter. If that level was out slightly, how far out would we be?
How far out would he be if it wasn't level? Jesse's just asked.
Not level.
What, the bubble?
So not horizontal.
Well, I mean, does it matter? He's only trying to do the height of the bloody thing. I mean, he's just showing you that he can put a level on a pole. That's it. I mean, this isn't part of the surveying. Look at it. Like, where are you meant to take the measurement from? Look at it. There's no way this guy is a professional. He's got a fucking cheap-ass level. He's got a pole that's obviously not part of the measuring thing. And then he's got I don't know, is that a folding ruler? I don't know.
No. So basically we know what the height of the antenna is above the road surface. There it is.
With nobody in the car. So the moment they get in the car, it's going to change. But hey, don't worry about that. It's only at the side in the parking lot.
Mounted on the car.
And Napa's annual clearance event.
So this is me attaching to the Louisiana State University's GNSS live stream. Basically, it's called a VRS system, and I'm going to be getting corrections in real time. I'm also logging the raw data at the same time to process later. I remember as we were doing that live stream, people did not like the sound it made. It was, it makes a beep every time it stores a point. So it's incrementing point by point, and I think I had it set to 10 meters. We had it set to 3 initially. It was way too many. So, yeah, distance, 10 meters. There it is. Right there.
He had it set at 3 meters, but then he decided to go for 33 feet.
And there's the height of the antenna above the road, 1.5.
Did he just do it? Hey, listen.
It's 10 meters. There it is, right there. And there's the height.
J-Ro, did you get that? Hey, one for the boys. I'll do it again, just to make sure you hear it.
We had it set to 3 initially. It was way too many. So, yeah, distance, 10 meters. There it is, right there. And there's the height of the antenna above the road, 1.53. And there I am going down the road. So about, I was going about maybe 40, 45 miles an hour. So that's the northbound collection. Now the next day...
Surveying at 45 miles an hour. Just as though he's driving over the bridge.
I did another pass, and you can watch this. This was a live stream that I tapped.
So just to point out, like he said, it's already been surveyed. It's already been built. They know exactly all of the points along it, where they were built, everything. It's all been triangulated. Jesse Kozlowski's just put a thing on the roof of his car, measured the height of it with a crappy level, and measured a thing, and then now he's driving over the bridge at 40, 45 miles an hour.
Into and soundly put me on, and I was doing that northbound up to the crossover. So this was us preparing that antenna height, and here's Dandy Pandy helping me get that height measured, making sure it's level, and there it is. Looks level, right? Can we all get a check on that level?
Looks pretty good to me, Jesse.
All right.
No, but I mean, you can measure the height of something on the roof of your car when nobody's in the car.
So there I am at milepost 0. That was my 0.85 and headed down the highway. So here's the data brought into Trimble Business Center, the software that I use. Looks like a blue triangle, right? So let's take a look at one of these points. We'll zoom in on point 1294.
Blue triangle.
What you're seeing here, this is a base station called Mary, and we're using carrier phase differencing to post-process these vectors. So that's what this is here. These are continuous streams. And this is the raw data here. So we're zoomed in on point 1294. As I said before, this was on Louisiana, South Zone, state plane coordinates in meters, northing and easting, and the elevation. Here's the latitudes and longitudes. Now, what I'm going to go into next is my attempt at creating a visual, some type of graphic presentation of this data. As I said at the beginning of this presentation, normally you would take these coordinates and elevations and go start making a map. That's how we use the data normally. We're trying to create and show you the shape of this bridge.
Normally they'd make a map, but Jesse's doing something different to show you the shape of a bridge. Isn't that weird? Keep an eye on that.
So what I did is exported the Earth-centered Earth fixed coordinates, and I converted them into a local system where I was facing eastward, and that's what you're looking at now. So I've just changed the view from looking top down onto the bridge, and now I'm looking sideways eastward. That's what I did.
Sideways eastwards. Right, so this is the bridge. Looking at it sideways. I don't know why.
And this, because I don't use three-dimensional graphics programs or animation. I don't have that skill set, but I could do a coordinate transformation that kept the integrity and the relationship of the values intact, but now I'm looking eastward. So let's see what we look at next here. Basically, I'm trying to get this view looking east from the from inside the Earth. So I've created a plane that encompasses the origin of the ECEF coordinates, which is 0, 0, 0.
This is where it gets a little bit tricky now. Come in, Iridium. If you know, we know Jesse Kozlowski isn't going to be around, right? We know Jesse's not going to come back. So if you want to come in and speak for him, if you think we're making any mistakes or anything about what Jesse's saying, because we're just going over what Jesse's saying. No incredulity unless you think Jesse's making mistakes about what he's saying. That's all we're doing. We're going over that. I'm just pointing out here that when I saw this, see this triangle here. So this is the base station and this is the triangle that he's showing you, right? So when he comes to this bit here and says you're looking outwards, and then he goes to this bit here and says from here to here to here, right? Is this the base station that he's talking about when he does his GPS that he was doing when he was doing it? And is it this triangle that he's dealing with here? This looks the same as this triangle here, right? Is this the bridge goes across there, and this is the base station, and this is the triangle that he's allowing you to think that this is here? Or is it like a lot of people have said, that this is a vertical triangle and this is the center of the Earth? And it's like a vertical triangle, or is this a horizontal triangle? Because I'd say when he drew this one here, I'd say this is the bridge that he drove across from here to here, and this is the base station. So this, to me, would have been a horizontal triangle, although it looks vertical on the screen there. I would have said that's a horizontal triangle. But up to you, whatever you want to do, without any incredulity. Everybody can decide all of this sort of stuff for themselves. Because I'd say Jesse's a little bit vague about what he's actually talking about here. But I'd say this is the bridge, this is the base station. So therefore, as he's talking about this, he's talking about sideways on, looking at the bridge sideways on from the side. And then as you go to here, this is a triangle on the horizontal plane. But make your own minds up what you want to think Jesse's doing, because it's all a trick.
Get this view looking east from the from inside the Earth. So I've created a plane that encompasses the origin of the ECEF coordinates, which is 0, 0, 0. And forming a triangle that way. And that's the plane that I'm in. It's almost like a section through the Earth there. So here it is. Here I am showing you that view again in my software and what I'm trying to create. And I hope that's coming through. Again, if anybody knows how to do animation and can actually move this camera and make this happen, that would be awesome. But the point being is that what you're going to now start to see is the literal shape of the bridge.
Oh, shape.
So here are, as I showed you before, the Earth-centered, Earth-fixed coordinates and their elevations. And now we're going to zoom in on a couple of these points. Here we are at point 44, right here. It's a little masked there, but that's elevation 5.72. Here's 573, 570. So the reason I'm doing this for you is that it's hard to visualize where these are in relation to each other. So I've created this view so that we can look at that.
Okay.
Let's take a look at some others. Now here you can see it's 5 7s. It's all these 5 7s. Now it's 5 8. Takes a little dip here. Then you see it's going to rise up. All right, that's the elevations. And this is one of the spans, one of the little shorter ones. It's rising up on a hump. And here we are looking at that hump. And this is what it looks like from the side view. This one's at 16.16 meters.
A hump.
0.665. Okay. Let's take a look at, this is the bigger marine span. There, it's up here in the 18.5 meters, 18.57. You can see that. And afterwards, it starts to dive down again and get back down to the level elevations. So let's hear. This is the large hump.
Right. So what he's doing there is showing that there is an elevation change, and when you measure that elevation change, you measure the elevation change to a reference, and he's just showing that this elevation change is shown within this plane that he's drawing on the screen right now. He's got it shown with the elevation showing as though it's like an elevation profile.
That's 0.1326 at 18.57 meters. See this line right here? That's the chord. I'm going to talk about that in a little bit. That's the chord connecting the from where I started and to where I ended.
Right, so where he started, this is important too. Where he started on the bridge and where he ended on the bridge. That's a straight line from one end of the bridge to the other end of the bridge. That's pretty important to what we're talking about here as well.
On the level points.
On the level.
I connected two of the level points. So I'll show you that in another couple slides. Okay, so there's that point right there. Now, what are these guys doing?
You'll see this is a familiar tactic. What are these guys doing? Something completely irrelevant. This is a magic trick. A sleight of hand. Look over here. Watch this. Because what is he talking about? He's not talking about the actual measurements, is he? Remember right at the very beginning where Jesse Kozlowski told Soundly that it doesn't matter what it looks like. If you measure, then you can tell what it is. And that's not going to change by what it looks like.
They're checking their pool cues.
Anybody check the pool cues like that? Anybody else play pool? Maybe not a lot of pool players. You put it on the table and roll it. You don't look down it like that.
Found this on the internet, and I'm showing you this is how you check to make sure your pool cue is straight.
No, you don't. You put it on the table and roll it. That's how you tell.
When you look at that pool cue like this, if it's warped, it's been sitting over in the corner for a long time, no one's used it, it's going to have a bend to it, you're going to see it, right? Makes sense, right? Common sense. So here's what I'm going to do with the view,
I don't know what that
this cross-section view. I'm going to start to turn it.
Right. He's going to start to turn it. But what does he mean by turn it? What does he mean? Let's see. Keep an eye on the picture and wait for the turn to see what occurs.
From the side, you can start to see now, there's a little hump there and there's a hump there.
Right, so you're looking at this end, and what goes on in between, turning.
And turn a little bit more, and each time I turn it,
Where's he turned it to? And what's happened? It's got a blue line.
Trying to get horizontal.
And there's a blue line and a red line. And he's turned it, but it's not changed in width. The start point's the same, the end point's the same. Let's see if he turns it again. Let's see what happens.
I zoom in so you could kind of see what's going on. This is the shape of the bridge starting to appear as I turn in my software.
What's he mean, turn? Is there anybody else that can understand what he means, turn? It's a straight line.
No,
well, it was a straight line to
I'm
start
not a
off
computer
with.
guy.
Well, the only thing that's happened here is that this blue line and the red line look like they were together, and now they're separating. So I don't know what he's doing. He's turning it to show you the shape of the bridge. It's crazy.
Making it curve.
Yeah, how's it turning? Let's go back. Look, watch it turning. How's that a turn? How's that a turn? He's not turned anything. He's just separated those bits. Crazy.
And that's the large. I think that's the large marine.
He goes into another distraction bit now with Soundly. It's worth pointing this out, because if somebody starts doing this to you and you don't really understand what they're talking about, because nonsense doesn't ever you can't comprehend nonsense. You need something to make sense for you to be able to understand it. You can never understand nonsense. It doesn't occur. There's no comprehending it. There's no understanding it. And that's what Soundly's doing at the minute. He's getting bored. He doesn't understand what Jesse's doing or what he's talking about. And he can't really engage, because he knows that if he asks questions that Jesse can't answer, he's going to get dismissed. So.
Span. There's a couple humps that, one of these humps, Soundly, you said you weren't even aware of, right? Humps. One of them? I forget which one.
Yeah, it's from the South Shore. If you're looking out at the 8-mile marine span, there's a marine hump directly behind it. I guess it's right about 9 miles.
Right. Oh, okay, that'd be that one.
And it's on the west lane, and it's I'll just from the angle that we normally look at, you don't pick it out, but it is there. You go back and look in the video footage. And
okay. Now, is it on the northbound side or the southbound?
It's on the north. It's on the southbound lane.
Okay.
Yeah.
That's what this is, the southbound.
Yeah.
Right. Okay. So there's that chord, and in fact, I think that's my next slide is to. Oh yeah, here's my last turn. Yeah.
Look at that.
Super globe.
That's a bridge. He thinks. Lake Pontchartrain Bridge. He's turned the shit out of it. I don't know what the fuck it is, and what his computer's doing. But I think his computer says, no, that's enough. We're not having any more. Computer says, no, Jesse, stop fucking doing that.
And so that's about as far as I could go. And after that, the thing would start to disappear. I don't know why, but the graphics would not allow me to turn this anymore. That's as
Like, it wouldn't allow him to turn it anymore. I'm not surprised.
far as I could get, and so I made a screenshot of that. So here's the side view again.
Right, here's the side view again. Right now, the plane that we're dealing with has elevation changes on it, and the line he's already said, the blue line, because these lines are on here. The blue line and the red line. They're the blue line and the red line. Here. This blue line and this red line are these lines that are here. Blue line. Red line. Same blue line, red line. He turned him. He's placed this separation area between them, as he's just shown you. Going here. Made it bigger. So I'll let Jesse explain where this gap came from.
So here's the side view again, and that's my midpoint, 981. If anybody wants to check this math, that's the chord. It's 28 point, like rounded off to 28.5, let's say, or 28.46 if you want to go to the nearest centimeter. And this is the length from the first level point that I kept in my sample to the last level point.
So that's the distance from him starting on the bridge to him finishing on the bridge. And this is the midpoint on the bridge.
And that's the distance.
So pretty interesting that shape that you just showed us there.
Soundly doesn't understand this. Jesse did say that's the chord. Don't think that's what he meant to say. I think he meant to say that's the sagittar. Because this is 28 meters above the chord line in a vertical direction to where the bridge is. So this 28.5 meter is on the vertical datum. The same as all of the elevations that are measured. And so there is a separation and a raise of the center above the chord line on the vertical datum of 28.5 meters. I think there was a guy called Blue Marble Science that said that's what Jesse went there to do, to measure the elevation above the tangent plane. He called this one the tangent plane. So that's what Jesse went there to do, to measure the elevation above the tangent plane. Jesse Kozlowski, by his friend Blue Marble Science.
Jesse, would you like to expound on that a little bit?
This shape right here?
Yeah.
It looks like a bow and arrow. Well, just a bow. Look, it does look like a bow. It looks like he's turned the shit out of his computer. That's impressive, that, though. For, Lake Pontchartrain. Isn't it, Blue? Nobody had... look, it Soundly. He's like happy. It's like, look at that shape. Bridge.
Well, it looks curved to me. Is that where you're going with this? I mean, it's kind of obvious, right?
Yeah. Looks a little similar to photography, don't you think?
Yeah.
What? Soundly thinks that's similar to the bridge, the picture he took from the side. Like crazy.
Oh, yeah. Well, don't let the cat out of the bag yet.
He's got over here in this bottom corner, he's got northings and eastings perpendicular.
Keep in mind, these are level. I mean, if you look at these, except for the humps.
Exactly.
These are all at 5.7, 5.7, 5.7.
Right.
5.7.
They're all at the same height. It's what he's telling you. They're all at the same height. 5.7, 5.7, 5.7. Listen to him.
The humps.
Exactly.
These are all at 5.7, 5.7, 5.7.
Right.
5.7. the thing was built to be level above that water. So
above what water? Remember, this line here is this one end of the bridge, and this is the other end of the bridge. This line here that he's put in. He turned the shit out of it to get this shape here, but that's what he started off as.
I don't know. Do we really need to talk about the difference between level and flat?
Exactly. It's level and curved.
Yeah.
Yeah.
So
it's actually amazingly level considering the distance that they had to build this thing.
It's amazingly level. I mean, look at Soundly. What's he doing? Can anybody else ever imagine you looking at that picture and saying, that's amazingly level? I hope you guys are keeping all of this stuff from Charles in the Discord, because I'm not getting any of it. It's wasted. None of it's being recorded.
Telling you, it's really
for 24 miles. They're very consistent, don't you think?
It's awesome. It is
it's an amazing.
It is an amazing
piece of architecture, really. Yeah,
it is. The way I phrase it is a monument to the curvature of the Earth.
It is a monument.
It's a man-made monument. It really is.
I totally agree with that.
It really.
Right. So the bridge that goes over Lake Pontchartrain is a monument to the curvature of the Earth. Even though it's over water. Strange. But hey, how much curvature of the Earth do you reckon you'd find over water? Do you reckon there'd be a 28.5 meter hump in the middle? I don't think so. I think that most people could say that there's definitely no such thing as a hump, even though we seem to have just drawn a picture of a massive fucking hump. Like, how can you look at that and say that's not a hump? Because that's a fucking hump. Right? Everybody could agree that we can look at that and say, fucking look at that hump. That's a bridge. It's higher in the centre, obviously, by a measured 28.5 metres. It has to be. Either that or Jesse Kozlowski's just bullshitting and he's turned his fucking thing on the computer to develop a 28.5 metre hump in the middle. It's a shame he's not going to come back and tell us what the fuck he's talking about. You have to deal with people like Blue Marble Science and these no-named iridiums just coming into the chat. Anybody can come into the Discord whenever you want. We'll get onto that in the end, FPV, we get round to it. Because they've set it up specifically for that picture. That's what it is. That's what they've done, Walter.
It really is. So, and you can't make this up. I mean, it's just, there it is. I mean, I collected the data.
You can't make it up, says Jesse Kozlowski. Can't make it up. Even though he's
just made it up.
Just literally made it up. But he says you can't make it up, so Soundly will go with that, surely.
To the curvature of the Earth.
It is a monument.
It's a man-made monument. It really is. I
totally agree with that.
It really is. So, and you can't make this up. I mean, it's just, there it is. I mean, I collected the data, processed it, output it. That's it.
Turn the shit out of it.
Here, and all this is just me trying to create views so you can see it.
See, all of it's just so he can make views, so Soundly can see it. Because Soundly's like he likes the shape of it. He likes the big hump.
So there it is. Now let's see where are we going next. Okay, so there's the chord. You can check that math if you want. This was pretty cool though.
Look again. Here we go. Another sleight of hand magic trick. Watch this. It's got nothing to do with it, but has it got something to do with it? Yeah, it's part of the trick. So
today I found this morning. I was just doing some searching on I forget what, but I came up. What I was really trying to find was construction, old historic, maybe photography of them building the causeway, and I thought maybe somebody captured some surveyors out there doing the work. I didn't find any of that, but I did find this article. This is from 2011, and somebody I haven't read the whole thing yet, but he is talking about computing the radius of the Earth using this bridge. So,
wow, somebody in some article from 2011 was talking about doing something that Jesse's about to have a go at doing now. No way. Imagine seeing that on the internet a day before.
So it's interesting. I'm going to take a look at this. I'm just showing you a couple portions of it. But look what I did here. I took a sample.
Uh-oh. You ready for this? This is the big wizardry.
Just creating that blue circle is the result of doing what's called a three coplanar points in 3D would describe a circle.
Damn.
So
3 coplanar points in 3D would describe a circle.
Damn.
Yeah. That's good, that, isn't it? Just 3 coplanar points. Where do you reckon those 3 coplanar points are? Which
all on the
points do you
same
reckon
plane?
you've got? Yeah. They would describe a circle. How do you reckon? Where are your 3 coplanar points?
Well, if they're 3 points and they're all in the same plane, they would form a triangle.
Yep. And it's a circle, so where's one of those points? Well, you'd think so, wouldn't you? Would you? Well, let's see how
In the
good your
center?
maths is.
This is great.
Yeah.
I selected one of my beginning points, one in the middle, and one at the end. I'm making sure that I didn't pick one of the humps. I wanted to make sure I was picking, the points on the level spans.
Right. The lower deck, as I call it.
And bam, there's the radius of the Earth.
It's Nathan Oakley's been asking for it for ages. All you needed was 3 coplanar points, and bam. That's Jesse. Do you want to hear it again? Because, we've been dealing with this and geometry and all of that. So some of you may still be wondering, 3? Right? So here we go again. There we go. It's from here.
I took a sample, just creating that blue circle is the result of doing what's called a three coplanar points in 3D would describe a circle. So I selected one of my beginning points, one in the middle, and one at the end. I'm making sure that I didn't pick one of the humps. I wanted to make sure I was picking, the points on the level spans.
Right. The lower deck, as I call it.
And bam, there's the radius of the Earth from that. And I did 2 of them. I didn't even do a bunch. I did a couple of them.
Just 2. Did a couple. So 3 coplanar points. One at each end of the chord. Obviously, he's already showed you the chord. That was at one at each end. And then one in the middle. How'd you get a circle from that? How'd you calculate that, Blue? Can you give us the method that Jesse did in order to calculate that? Anyone? Can anyone explain Jesse's maths of how he came up with the radius? from driving over Lake Pontchartrain Bridge in his car. On a weekend away with Soundly at the hotel room at the Marriott Hotel. I don't know what floor. I'll take a guess at a room number. With Soundly with his camera looking out the window. You reckon they all stayed at the Marriott? It must have cost a fair bit, you know. This operation that these guys have done. I mean, Jesse's measured the radius of the Earth by driving his car over the bridge twice.
And then I looked up a calculator that gives you the radius by latitude, and we're right about at 30 here. The south end of the bridge is at 30. The north end is at 20 minutes. I just went with 30. And
so let me pause you here and just make sure that everybody in the chat or anybody that's listening right now that may have started reading the chat and not really paying attention, pay attention here, okay? Jesse has measured the curvature of the Earth.
He hasn't, but Soundly's doing well, right? Nicely. Go on, Soundly, you build this one up for Jesse.
And he has measured the radius.
Measured the radius? Jesse has? Anyone want to know why Jesse's not back around here? Obviously,
Because
nobody ever told Jesse, Nathan Oakley. Because he wouldn't keep asking, would he? If Jesse's already done it. Nobody's ever been over there to Nathan Oakley, have they, and told them about Jesse? Why is that? Been asking for it fucking ages. It was already been done. Crazy. Soundly believes him. I'll listen to it again.
Voice.
There we go.
Everybody in the chat or anybody that's listening right now that may have started reading the chat and not really paying attention, pay attention here, okay? Jesse has measured the curvature of the Earth, and he has measured the radius based on that curvature. That's what Jesse did.
Yeah,
I did.
So there is.
He did. He's confirmed it. He did. He said he did.
There is no presupposing R anymore. Okay.
No, we have R.
It has been directly measured by Jesse Kozlowski during Globe Earth Tourism 2019.
Globe Earth Tourism 2019. Come on, guys. 4 years on. Jesse did it 4 years ago. What are you bothering about? There's a 28.5 meter hump in the middle of Lake Pontchartrain. If you don't know that, then come on. You're going to see it in a minute.
Yeah.
So
Roger that.
Yeah, Roger that.
R is no longer presupposed.
No, it's actually
it was.
It was presupposed until Jesse Kozlowski measured it, going over the 28.5 meter hump in the middle of the Lake Pontchartrain.
It's monumented.
Exactly.
It is a concrete monument, 20 some miles long. So here's what happened here. I did a comparison of what, and again, I didn't sit here and calculate this myself. I just picked these 3 points. I guess you could pick a whole sampling of them.
Did you hear that? What Jesse didn't do.
It is a concrete monument, 20 some miles long. So here's what happened here. I did a comparison of what, and again, I didn't sit here and calculate this myself. I just
He did
sit there and
calculate
calculate it himself. He didn't do that. He got a calculator. triangles, Blue. Do those triangles have 180 degrees? Would they follow the triangle axiom, Blue? Because you've got a bit of a sticky situation there, haven't you? Stolen concept, we might say. You're heading all aboard the stolen concept train with Blue Marble Science. He'll reach destination in some point in time. You never know.
Pick these 3 points. You could pick, I guess you could pick a whole sampling of them. And by the way, this is just the southbound lane.
Yeah.
I didn't even look at the northbound yet. But we're within 0.5%, right? Somebody can check my math, but that's that is what we see here. So they did a great job.
Measurement, I'd have to say, Jesse.
I think so. That still won't stop me from going up to Maine to do the Albert.
Ooh. Okay. Check this out now. Because
wait, maybe he does live in Maine.
Well, listen.
Maybe. I said maybe.
Yeah. So far, we've got Soundly and Jesse talking about Belu and going and meeting George, going for a holiday down at George's Rainy Lake. I don't know whether Blue, did you go? Were you there as well, Blue, or was it just Tim Osman, George, Jesse Kozlowski, and Soundly? I don't know whether Blue was there or not. I don't want to include Blue. I don't think he was that tight. I think the other guys were doing that. Right, so this is what Jesse's now going to name drop some other one, right? You can listen to this.
I think so. That still won't stop me from going up to Maine to do the Alberuni method. I want to definitely meet up with Just a Maniac. He's
Just a Maniac.
He's on YouTube. Just a Maniac. Take a look.
He's not on YouTube. I think he goes by the name The Main Surveyor, not Just a Maniac. It's not worth looking for Just a Maniac. Look for The Main Surveyor. Obviously, he's in the Facebook with Jesse. Yeah. He's not a real surveyor. But
meet up with Just a Maniac. He's on YouTube. Just a Maniac. Take a look. A surveyor up in Maine, and he's in my Facebook group, Geodetic Surveying Facebook group, and he did the Alberuni method using zenith angles to the horizon of the ocean from a mountaintop.
Wow, using an angle from a mountain. That's one angle from a mountain. You know what we say? We say you can do fuck all with an angle. And I'd say that to the Main Surveyor as well. But sadly, the Main Surveyor and Jesse Kozlowski are no more. They've both done a Jesse Kozlowski and fucked off. They're never going to come back to explain any of this to anyone. So make your own mind up about what everybody did. Humps in the middle of Lake Pontchartrain, 28.5 meters. Jesse Kozlowski measured the radius, and sadly he's gone now. He can't go over to Nathan Oakley and say, yeah, I did that. There's just none of that. It's never going to happen.
And this spring I got to go do that. It's just something I want to do.
I don't know whether he actually ever did do that, because he wants to do it, measure an angle from the top of a mountain to prove fuck all, really, just to show everyone you can do fuck all with an angle. But these guys, you know, like Jesse Kozlowski, he'll be able to measure R. He's marvelous at being able to do that. Jesse, you know that Nathan Oakley got really upset about you can do fuck all with an angle. Well, I think that's because Nathan Oakley wanted Blue Marble, Jesse Kozlowski, to be able to go up a mountain, measure an angle, and get the radius of the Earth. Blue Marble, keep saying that. That's that because Blue's in the chat. Blue, are you in the chat? Yeah. Yes, Bev, those triangles are Euclidean. Fantastic. Stolen concept on the way. You can't measure triangles and use Euclidean triangles to say that it's not Euclidean. Can you, Blue? You can't. That wouldn't work, would it? You can't get Euclidean triangles to measure the radius to be able to say it's non-Euclidean geometry. You fucked it, Blue. You can't use Cartesian coordinates to say not Cartesian coordinates. We've been talking to people, mainly Wally, but a lot of people, and tried to introduce them to this idea of a stolen concept. Stolen concepts, when you use a particular method or whatever within your formulation of your logical method, to then end up with the conclusion that the things you used weren't the things that you used. So what Blue Marble's talking about really is that you use Euclidean triangles to be able to say that the triangles that they use were not Euclidean triangles. It's a long, complicated method where you end up talking about and not that. That causes you to be speaking like it's a nonsense unless you're within this ridiculous concept of a dogmatic model. So you have to point out to people that the dogmatic model requires a stolen concept of Euclidean geometry to end up with their model that has non-Euclidean geometry. It's very, very strange. Blue Marble will be explaining it all at some point. The stolen concept of the globe model. The dogmatic globe model.
So what are these guys doing?
He's doing it again.
Well, they're checking the lumber, right? Make sure it's straight.
He's just told soundly that he's measured R. He should be a god amongst men now within the dogmatic globe community. But now, look what he's doing. He's talking about guys looking down pieces of wood. For what purpose? Mainly because Soundly has got a picture.
Everybody understands this, but everyone freaks out when they're looking at your photography thinking you have somehow magically changed the shape of the bridge. It just, I don't know. I shake my head. I don't know how to I can't take that seriously, I guess. But that's what they want to do. So here, let's take this circle. We're going to turn it a little bit, turn it a little more. I mean, doesn't that make sense? If you turn the thing and look at it straight on, it's going to change shape. Why? What? From perspective, right?
Anyone get that? That was obviously a globe magic trick. Will we go back again? Turns a circle. What's this? See whether you're fooled by this. Soundly is. This is especially for Soundly.
This circle, we're going to turn it a little bit, turn it a little more. I mean, doesn't that make sense? If you turn the thing and look at it straight on, it's going to change shape. Why?
Can you remember at the beginning where I pointed out that he told Soundly that the circle doesn't stop being a circle because you look at it from a different angle? It's still the same thing that you've measured it as. So why is he doing this now? It's like a reversal of what he's already shown. It's like Soundly's the seal and he's just throwing him a fish. Turning circles for perspective. This is low grade flat earth society shit. This is
From perspective, right? So that's why I made this video called The Clown Frown Found, because we found the clown frown. And this is the thing that flat earthers want to see. They want to look out on the horizon and they want to see.
Now they're talking to flat earthers now. This is specific for flat earthers. It's got nothing to do with the actual shape or anything. This is not surveying methods or anything.
A curve like this. But that doesn't make any sense because the distance from here to here is small compared to the distance from here out to here. And this telescope is set level, and you notice that the horizon does not rise to eye level.
Yes, we know that. The horizon does not rise to eye level. We know that. Everybody knows that, I think. Apart from, some flat earthers say that it does. Allows Jesse Kozlowski to do this. When those of us that actually know that the horizon does not rise to eye level, that's a non-argument. But Jesse Kozlowski's allowed to come out with this argument now because a certain few people do actually say that. Now, I think they're Flat Earth Society too. Because if one of them says that it does, then the other one says that it doesn't, and it's just backwards and forwards. Ridiculous.
This thing's only about 12 feet elevation. Yet I'm way over top of that lighthouse. Now, I'm going to just show you this because it helps, I think, get across this whole idea about, what is it? The angle of attack? Is that what it is?
Right.
Okay, so everybody should understand that this is a side view, right?
This is Robotham numbers. This is Robotham mathematics. This is Pythagorean, Euclidean formulas. All of this sort of stuff. Isn't that right, Blue? Totally like Blue Marble says. Totally Euclidean triangles involved in all of this here. It's just a circle.
This is, you're here and you're looking that way, right? So what happens if we turn that chart? So if I'm holding that chart in my hands and I turn it and turn it a little more, now I'm looking down it and everything's compressed, right?
Right. What's he talking about? I mean, look at it. If this isn't wizardry, I don't know what is.
He's just describing what he did before.
He's just doing the perspective thing. He told him at the beginning that it doesn't matter what the shape is. It's not going to change by the way you look at it. And now he's just saying, look at it a different way.
Yeah. So, in fact, someone who is looking at that and is not taking into consideration what he said before, he would be fooled by himself.
Yeah. Yeah, and Jesse Kozlowski would be able to say, no, I said at the beginning, don't be fooled by this sort of thing. People don't seem to realise this. And now he's using that very same tactic. He's a wizard, telling you. It's either that or Soundly's just playing the part of the fool. The agreeable fool. Clever trick.
Right?
Yeah.
Isn't that what happens?
Right.
It's not what
so
happens.
Now, let's compare that to this. If I set this aside, let me move this over a little bit and bring the chart here.
Now.
And we're going to just zoom in because this thing's only about, 8 miles away. So we're going to just zoom into this little area right there. And we're looking in that direction, which looks that way. See how that looks? You're looking out. Okay. And so the curve drops away from the horizontal tangent downward like that.
Drops. Right, that's the 28.5 meter hump that he's done. Obviously.
That's how it works.
Right.
Yeah. I don't know why people can't understand that.
So that's a drop, right? It's
Yes,
not a hump. It's a drop. This is the point that I was wanting to have a word with Jesse Kozlowski about, right? Because at the beginning he said the water level drops from horizontal.
It never reaches horizontal. That's why they say it rises to eye level, because then people can think, oh, if it is not rising to eye level, it means to crosshairs there is a drop. This is the trick.
Yeah, but he has just shown a sagittar of 28.5 meters, which is up from the chord, from each end. Literally, that's what Jesse Kozlowski showed. He showed one point at one end and the other point at the other end of the bridge, and then a 28.5 meter hump. So where's this drop coming from? You can't have both, can you?
Of course, but you cannot have this globe without contradictions.
Yeah.
So, no.
So there's a blatant contradiction here. He's showing that there is a 28.5 meter hump, yet he's showing here a drop.
You know,
seems pretty straightforward to me, Jesse.
Now, when were you in China? You took this picture, right?
I've never been in China.
Oh, well then there must be a soundly in China.
See, now this is something really strange here as well. I don't think Jesse understood the brief for the soundly picture completely. Somebody please tell me, what's Jesse going on about here? Right? Soundly in China.
That's how it works.
Right.
Yeah. I don't know why people can't understand that. You know.
Seems pretty straightforward to me, Jesse.
Now, when were you in China? You took this picture, right?
I've never been in China.
Oh, well then there must be a soundly in China, because somebody in China took this picture of this bridge. And you know what? I think they're I think they took these lamps up here and they used them as a fence.
What's that? What's Jesse talking about?
Some kind of code. I don't know.
It's just a hump, isn't it? Like there's a curve there. It's like, is Soundly the only guy? Well, that's a hump, isn't it?
Yes. So now he's showing how hump is looking like. Really.
Mm-hmm.
So he is now showing real hump.
Shows you what an actual hump looks like. That's not the bridge that Soundly did.
Yeah. Yeah.
Doesn't look like that at all. So, yeah, Jesse Kozlowski's missed the brief of what he's meant to be doing, because that's crazy.
You know, to prevent people from jumping off or something. And you know what? I think the pilings, you know, you see these columns and these piles, they just had to use more and more and more of them. They're just closer and closer together. Oh. Okay. So here we are in 2005.
Again. Another one?
You've mastered the Mandela effect, haven't you? You've gone back in time and you took these pictures, didn't you?
Grandpa Soundly does have a time machine, so you never know.
So, you know, I found these today and I thought, oh my God, like, okay, so everyone's like attacking you for the pictures you've taken, but these pictures have been taken before.
Everyone's attacking him for taking pictures. And then what are these pictures? What's he talking about? It's crazy. I don't even know what's going on here. I bet Soundly's looking a bit confused as well.
I think that he is laughing at Globers now.
Well, yeah, I think that's what he's doing. He's always been, his brief was to just go along with the official narrative, and Soundly's going to go along with whatever. Soundly's pushing his picture.
And it was you, wasn't it?
Exactly. I went back in time.
So now here's this History Channel did this video. I think it's from like 2003. And look what I found. Dun, dun, dun.
Like, what? Like, what's this? A circle are doing the time. That's a hump there, definitely. And this is history. I don't know. I don't get it. If anybody knows what the fuck Jesse Kozlowski's talking about in here, no surprise he can't come back again. Because this just doesn't make any sense.
Look at that. Oh my God.
He's like laughing at them. He's laughing at Soundly, literally laughing at him.
Oh, see?
Look at that one. Yeah,
it's robotic.
See it.
Yeah. Soundly's going to go, oh, there's a little bit, I think I can see a bit of curve there in that one. Jesse, I haven't got a clue what the rest of them were all about.
It kind of going over the horizon, maybe, right there at the very end.
Yeah,
looks curved to me. It's roboting, this stream. Yeah.
Oh, is it?
Yeah, your stream is breaking up, but yeah.
There you go. Should be better.
Me. Dun, dun, dun. So yeah, that was aired on in 2003.
Nice.
Now, this is what we all came to see. People who look at Walter, people that look at Walter Bislin's blog will recognize this styling.
Walter Bislin, shout out to Walter.
Go. This is the big trick now. Walter Bislin. So, build up. That was just the build up. This is the big trick. Forget about the radius stuff. That means nothing. You know, this is where we go. This is the big trick.
Bislin, who has been in the chat. Thank you, Walter.
Wait.
Awesome.
Go
on. I'm really sorry. I have to do this. I'm gonna give some credit to Nathan Oakley. Sorry, have to do this. But it's Walter Bislin's perspective denying Earth curve calculator. Thank you very much.
Well,
sorry, I had to do that.
Yeah, Nathan's been doing that for quite a while, and it's allowed everybody to believe that there is such a thing. All it actually does is it calculates the amount of curvature you would require in level for you to imagine you're living on a globe, the dogmatic globe. That's what those calculators do. So it's about time we started being honest with what the calculators do. They allow you to believe that level curves the amount that you can place into the calculator. That's it.
For all of your awesome work, really awesome.
Yeah, I'm just smiling here. So he took the data that I sent him initially and created this app, and it's under development. So let's realize there's still things to be done with it. And
right. So Walter Bislin took the data that Jesse gave him originally to create an app. Put it about again so you can listen to Jesse say it.
Awesome.
For all of your awesome work, really awesome.
Yeah, I'm just smiling here. So he took the data that I sent him initially and created this app, and it's under development. So let's realize there's still things to be done with it. And I'm not really good at using it. I'm going to try my best to demonstrate it tonight. But so here's a kind of a side view, you know. But now you come over here, and this is about from, like, say, the hotel, and it looks a lot like your photo. In fact,
it looks a lot like your photo. That's definitely got a hump, right? It's not a drop. That's a hump. We can all agree on that? Definitely a hump, and definitely not what we see in Soundly's picture. Or do we? Is that what you see? Has anyone ever seen that?
It's a hump.
That's a hump. For sure.
The rental car I had was...
This is where you get to hear, like you said before, Paper. Listen to how he's taking the piss out of them here.
From, like, say, the hotel, and it looks a lot like your photo. In fact, the rental car I had was a submarine car. I had to go underwater, you know.
So,
that's over.
So just to clarify, this
he had to go underwater in a submarine car. Jesse Kozlowski. That's a hump. Definitely a hump.
This is your data that Walter has taken, and he has rendered.
That's Jesse's data. That's got a hump. That says he had to have a car, submarine car. I don't think anybody. I don't even think Jesse was taking this seriously. He can't be. He's laughing about submarine cars. It's a pity he's never going to come back and tell everybody whether he was actually laughing at Soundly or not.
It in a 3D space.
Yes.
And this is what we're getting.
Yes. And
very interesting.
Yeah. It is really. It's just awesome. So,
I noticed there's no curve the other way there. It should be really, shouldn't there? It should be a curve both ways. If you can see that much of a curve on the hump there, I mean, how big's the circle? Anyone want to try and imagine how big the tiny Earth, right? Such a big hump.
Tiny Earth, and not spherical, but cylindric rather.
Yeah. Yeah. And that's the data that Walter Bislin got off Jesse Kozlowski that made that. I mean, he measured the radius of the Earth off that. Looks fucking tiny to me. That's 23 miles across there. 23.7, sorry. It's definitely a hump, right? Absolutely a hump.
These are he took the XYZ coordinates. He wrote his own program to...
Hear that? Listen to this. This would be the best bit, right?
It is really. It's just awesome. So these are he took the XYZ coordinates. He wrote his own program to convert them back to Latin long.
He wrote his own program. Walter Bislin wrote his own program. Why wasn't there a program already there? I ask you that. Why wasn't this program already developed? Mainly, I'd say, because what they need to do is they need to fit this picture to Soundly's picture. That's why this has been made. Not because it's got anything to do with anything other than them pushing a false narrative, trying to convince people that ridiculous surveyors drive over bridges to come up with these software writing people that make calculators tell you how much a straight line has to bend for you to imagine you live on a fucking globe. But that's what we're doing here. It's a shame Jesse Kozlowski's not going to fucking come back and explain this to anyone.
He's done absolute geodetic software writing. I mean, it's like he's got all the calculations in here.
He's got all the calculations in here in his absolute geodetic software writing. He meant to say wizardry. You listen to it again. He meant to say wizardry. He just had to change it to software, geodetic software writing.
It's just awesome. So
here we go.
These are he took the XYZ coordinates. He wrote his own program to convert them back to Latin long. He's done absolute geodetic software writing. I mean, it's like he's got all the calculations in here. It's awesome. So, well, here's the side view.
Watch this. This is where the looking down the pool cues and the pieces of wood have come from. The big trick, right? Look at it.
And, you're not going to see the curve from the side.
Right. You're not going to see the curve from the side.
You see, that's the whole point. But you can measure it. It's there. You can measure it.
You can measure it, he says. 28.5 meter hump. You can measure. It's there.
The actual shape, and I'd like to point this out too. We're talking about the actual shape of the Earth. This is like going out and touching it. It's like including a whole other sense. It's not just an observation of a photograph. It's not photographic. It's not optical. There's no refraction involved here. This is us going out and literally touching the surface of the bridge.
It's not. It's Jesse Kozlowski driving over a bridge, coming up with a load of numbers, him handing them over to Walter Bislin, who writes a program to come up with this bullshit. That's what it is.
And that's saying, right. This is what the geometry actually is.
It's not. But, I mean, if anybody wants to come out, we know Jesse Kozlowski's not going to come back. But if there is somebody out there that wants to attempt to justify what Soundly's just said, the actual geometry, he doesn't understand a fucking thing about geometry. But that's what Soundly's just said. This is the geometry of the fucking bridge. Like, what does that mean?
This is us going out and literally touching the surface of the bridge. And that's saying, right. This is what the geometry actually is.
No, the geometry is Euclidean. We know that, but not because Jesse's touched the surface of the bridge, which he didn't. He drove it in his car. But hey.
So yeah, let's tie it both together. You're right. There's no telescope involved here. This is just 3D points as a result of that GPS survey, which matches the old school survey those surveyors who laid this thing out and the guys who built.
He's trying to say that matches the original plans for the bridge, for fuck's sake. I mean, they triangulated it. He just said at the beginning that they did the triangulation. I mean, look at the fucking state of that. And he's trying to tell people that that matches the original surveying things before GPS. Like it's a joke. The guy drives over the bridge with a car and compares that fucking ridiculous shit that Walter Bislin's given him to the original surveying plans, for fuck's sake.
Survey, which matches the old school survey. Those surveyors who laid this thing out and the guys who built this level across that water. I mean, like I said, it's a standing monument to the curvature of the Earth. There it is.
That's Walter Bislin's done that, right? Walter Bislin, Jesse Kozlowski. You can't really put soundly in here. He's just the useful idiot. Walter Bislin and Jesse Kozlowski. Jesse Kozlowski isn't going to come round and talk about it. And Walter Bislin, definitely, he's not going to come round. He's raking his stuff up now with his little app or whatever.
And this, again, is the Earth-centered, Earth-fixed coordinates. So these are X, Y, and Z coordinates plotted in a 3D space.
Yes.
And this is what you get.
That's right.
That's what you get when you plot the coordinates. 28.5 meter hump, that is. Anyone who believes that? I'm pretty sure that none of the Globe guys either. Is Blue still around? Blue can't really believe that. I bet there isn't really any Globers out there that go with that. I mean, that's fucking ridiculous. 28.5 meter hump of water in the middle. Really? Despite the fact it's impossible, right? We won't worry about that yet, but what this is showing here, that's why Jesse Kozlowski's never going to come back. That's why Blue Marble Science can never back up his 28.5 meter hump, because it's literally impossible. Water can't do it. It can't put itself in that negative state. It can't hump 28 meters. It's impossible. Literally impossible. You want to have a conversation about it? Come on, I'll tell you, it's impossible. Can't happen.
So, and again, I just want to point out that, you know, that is the northbound. There I am over in Mandeville, turning around, and then I came back and did the southbound. So, and there it is from the side. You're not going to see curvature from the side. Just, you know, you're talking a couple of 100 feet on end to end from the side view. So just keep it in mind. This is how it works. Everybody's checked a piece of lumber. Make sure you're buying leave all that curvy lumber over there in the pile over there. And you.
Right. You're doing this with lumber, right? Has anyone ever done that with a bridge? Has anyone ever picked a fucking bridge up and looked straight down it to be able to shape the shape of the fucking bridge? It's going over a lake. What's he talking about? This is a joke, but this is 2019, and this just shows you what was going on at that time. How deep into the model these guys already were. They can't separate themselves from this model. And they've fooled everyone. Everyone within this arena, like everyone outside this arena, that's why I put on the GIF. They don't give a shit. They just won't entertain any of it. You'll never find a surveyor coming in here to back this shit up from Jesse Kozlowski. Jesse Kozlowski won't be coming back here ever again. He can't talk about it. and nobody else will ever defend it, other than people that don't know anything about this, the trade or anything. Doesn't matter. Surveyors know that the Earth is not flat, but they also know that water doesn't hump 28.5 meters in the middle of a fucking lake.
Walk out with nice straight pieces, right? So here is the side. There's the side, one of those marine spans, right?
Right.
So their History Channel took. There they are. They're out there in a boat. You haven't yet taken a picture like this, have you? From the side. You haven't been out on.
I haven't been out in a boat, right?
Yeah. So they did.
So Soundly's never been out on the boat. Never done it. Soundly's getting a bit yawny. It's getting boring for him.
Did it. They did it for us. Okay, side view, straight on view. Side view, straight on view. Side view, straight on view.
Right.
Just think lumber.
Yes. Exactly.
See, he's doing the magic trick with the lumber to try and convince Soundly.
Exactly.
Yes. Okay. This is not hard, people.
Well, just to point out that marine hump is, I think, a mile long, maybe? The total marine hump?
We can measure it.
Okay, yeah.
You know what I mean?
Data.
I've got
We
the
have
data. It's a gentle rise. You come up and over and you go like that. And I've got all those points.
Right.
And
so this is a wide angle camera. I like to point out a wider angle than normal camera, probably like a 50 millimeter camera. And we're getting less than a mile, side to side here.
But there is a hump. You can see that. You can literally see that is a marine hump, so boats can go through it. That's the reason why they have these humps in it. And you can see that it is.
And across the whole picture from right to left, there is difference between edges and middle.
Yeah.
Between water and
bridge.
And this bridge. So if he's talking about that, this picture is showing that bridge has the same curvature as the water. It is not. We can see that in that picture.
Yeah.
That the curve is different on the bridge and different on the water. Or I would say that there is no curvature in the water. So this bridge is curving.
Yeah, it has to curve in the other way, doesn't it? If you're looking that way, the water has to curve the same as the way it does when you're looking the other way. Makes no difference. According to the globe model, which way you're looking at it, the curve's still meant to be there. It's crazy. But Soundly doesn't see it, and nobody else does either, right? It's an elevation profile he's trying to do.
Yeah.
Maybe a mile. And whenever you zoom in from the side, you're only going to get like a handful of pylons. Like,
if you zoom in,
you're just not going to be able to get any amount of length worth looking at of the causeway from the side. So it's just so silly when you hear people, say things like, go to the side, take a picture from 90 degrees away. It's like, you have to be 20 miles away to do that, and you'd have to have a 60-degree field of view. How are you even going to see the bridge? You can't even see it from that distance.
Yeah.
Not to mention that both ends are going to be falling off behind the horizon.
Both ends. Both ends will be falling behind the horizon. He's going to have a hump. He doesn't have a horizontal horizon. A plane of the horizon being horizontal. Soundly doesn't even have that.
It's amazing we had to go through this to make the obvious obvious, but it sure was fun. I was glad to do it. So there it is. That's the Q-stick lumber view. Okay.
Yeah.
And that's what it looks like. So
can you stop for a second?
Yeah. Go on.
Can you see this these poles?
Yeah.
They are parallel to each other.
Yeah.
How they can be parallel to each other when it is curved? They should diverge. They are not. They are all vertical, really vertical. And they should diverge across this curvature. And they are not. That's why I know that this picture is faked also.
Mm-hmm. This is a water tower that's 3 miles, I think, beyond the end of the bridge. So this is a water tower that's 27, 28 miles away. Look at the size of it.
It's still above this bridge, and should be down over the curvature.
Well, yeah, they have to have it up pretty high, don't we, for water?
Yeah.
And look how big do you think it is? It's huge. It's not that big. There's something going on. It's optical, obviously. There's loads of optical shit going on over here. There's no cars on the bridge there either. So I don't know what's going on.
Yeah. And I think the next slide is what I just got minutes before we went on
Walter,
air.
Yeah, Walter sent this to us just before we went on air.
Oh, wait. First I have to...
Where is it?
No, it's going to be...
He's advertising FE Core. Definite Flat Earth Society. Jesse Kozlowski. You should all know about this sort of shit. FE Core, Flat Earth Society. Jesse Kozlowski presenting Flat Earth Society shit.
It's the last.
Oh, it's the last thing. Just hang around. It's almost here.
Yeah.
The money shot is almost here. We've had a lot of money shots, but this is the really money shot.
I wanted to mention the FE Core Flat Earth Scientists because they just put out a video or a couple days ago, and I listened to some of it. They've got quite a lineup of experiments that they're going to be doing involving lasers, some type of force the level tests. There were a number of them. And, I'm offering the data here. If you want to analyze this data, here are the raw files. These are binary encrypted files. No one can, you can't tamper with that file format. I've exported the file format to an ASCII RINEX converted, RINEX stands for Receiver Independent Exchange Format. That is available if anybody wants to post-process this data. Here's the navigation file, and there it is.
Boom! Look at that.
Do you catch Soundly? Which he was caught in the middle of a... I don't know whether I can... Here we go. Let me get this. Right, watch this. This is Soundly. He's just about to do the thing, and this is how bored he was. He's holding back a yawn.
Yes, yawning. He's restraining himself to open mouth.
Yeah. I'll put it there. It's like he's Jesse's just showing the picture. Watch.
process this data. Here's the navigation file. And
He's yawning. Go on.
there it is.
He had to gulp it down to bring it back. Right at the moment, his picture was shown.
And there it is.
Boom! Look at that. Wow. Wow.
Now,
you can even kind of see some refraction going on there.
I think so.
Look at that. Refraction in the observation versus the actual geometry of the bridge. Side by side. Compare and contrast. Compare and contrast that with Walter Bislin's models. So we basically have three different things here. We have Walter Bislin modeling it, saying this is what it should look like. You go out and measure it. You say this is what it feels like.
Look at this. It's crazy. So, listen to what he's saying. Again.
Wow. Wow.
Now,
you can even kind of see some refraction going on there.
I think so.
You see the bits here? Look, I mean, what happened here? Even Walter Bislin couldn't get the picture to match Jesse's things. I mean, it's nowhere near. So what's going on? I think that's what he calls refraction, that.
Look at that. Refraction in the observation versus the actual geometry of the bridge. Side by side. Compare and contrast. Compare and contrast that with Walter Bislin's models. So we basically have three different things here. We have Walter Bislin modeling it, saying this is what it should look like. You go out and measure it. You say this is what it feels like. And I go and photograph it and I say this is what it looks like. And
Jesse does what it feels like.
Models. So we basically have three different things here. We have Walter Bislin modeling it, saying this is what it should look like. You go out and measure it. You say this is what it feels like. And I go and photograph it and I say this is what it looks like. And
correct.
They all agree with each other.
Yes.
They all agree with each other. Look at them. Look, how does that all agree with each other? Jesse, this is what it feels like when you drive over a bridge in a car. And Walter did the model for what it should look like with the way he wanted it to. He couldn't even make it look like Soundley's picture. It's so bad. So...
And keep in mind, he could not import all the points. He sparsely displayed. I collected a lot of points. Let's put it that way. 30.
I thought he said every third point or something like that.
Yeah. So he didn't need. In other words, he didn't need. Let me get my mouse going here. He didn't need ... That's sufficient.
Right.
To show you the shape. Sufficient. You don't need to fill it in any denser than that.
That is amazing right there, man.
Now I think it is great. And yeah, so he's working on the app. I'm going to just show the app right now without the photo.
Well, hold on before you leave here.
All right.
Let me make this point and let me make it very clear for every debunker that's out there.
Right, this is good.
Every debunker that hears on a day-to-day basis, it's all to do with refraction and atmosphere and optics and all that. All of those arguments are completely defeated. Every single picture that we have showing curvature is now back on the board because here we are We have measurements showing what the actual geometry of the bridge is, completely independent of any optical observation.
Right, we've got actual measurements. Jesse Kozlowski drove over the bridge doing car surveying. So you can tell everyone, Jesse Kozlowski did car surveying and 3 coplanar points made a triangle, and he did radius of the Earth. Then Walter Bislin got hold of the stuff from Jesse Kozlowski, made his own program, and now look at that. He can feel the surface of the bridge, the actual geometry. As if there's some sort of Lake Pontchartrain bridge geometry that Walter used. He developed it. Walter Bislin's Lake Pontchartrain bridge geometry. Confirmed by Soundly.
And it matches the optical observation. And if anything, the optical observation is showing that there is actually refraction occurring that's making it look less curved.
So it all matches the picture. Imagine that. Imagine how that works. The picture comes first. Jesse drives over the bridge and gives a load of stuff to Walter Bislin. And Walter Bislin makes a thing that sort of looks like Townley's picture. What a coincidence. I bet nobody could see that coming.
So all of these arguments coming from flat earthers defeated in one stroke right there, just by that data that Jesse went and collected.
What? Right, you flat earthers. See, that's why flat earthers have never bothered with this. Jesse got some data that defeats flat earthers. It's amazing. Now, most of people don't really bother watching these sort of things. And, you know, like, if it hadn't have been for us specialising in this sort of thing and me coming into it, specifically wanting to talk to Jesse Kozlowski, I'm not too sure who'd have bothered with this, because, I mean, who bothers about geometry and triangles and stuff? I mean, there isn't anybody to go up against with any of this. You can't talk to Soundly. He's only taking pictures. You can't talk to Jesse Kozlowski. He's done one. He's done a Jesse Kozlowski. You can't talk to the main surveyor because, I mean, he obviously wasn't a surveyor and he's done a Jesse Kozlowski too. There's nobody else to talk to. You just have to take these people's words for it.
So use it. Use the data. Use Walter's application.
Yeah, let's take a look at it. And again, it's under development. So let's
development.
Just see here. When you go to this his app.
That's awesome, isn't it?
Isn't it fantastic? And that's just what I needed. I wrote him an email. I said, can you work with these 3D points and bring them in? Because again, I have to emphasize, like what I said at the very beginning, this is not something we would normally do as part of a survey, you know, of a bridge. You would survey the bridge and then you'd be producing AutoCAD maps of the structure, you know, to be used in engineering. We do see more and more 3D type use now that we're doing lots of laser scanning, and drones are involved doing laser scanning and photography, and so 3D software is being used a lot. But like I said, I don't have that, and I can barely operate this app. Let me put it that way. But I'd like to learn how. But it's
the 28.5 meter hump in the middle is crucial. And that's, I personally think that's why Jesse Kozlowski isn't around anymore. He's left it in the hands of Blue Marble Science. who's had to unclamp the center point. That's where the 28.5 meter hump has come from. When people look into it, and most people haven't even scratched the surface of how deep this particular rabbit hole goes within geometry. But 28.5 meter hump, that's 3 times over the possible negative pressure state that water isn't possible to be able to do that with.
Pretty cool. I mean, you throw the points in here, you can see, you come to the side, and this, as you zoom out and you go all the way to the side, the span flattens out, you know, just the way it would if you were out here in a boat.
Yep.
You come over here, you go up into the hotel room, you know.
Exactly.
I think he showed me how to. Let me see if
a point on the hotel room, right?
Come on.
Yeah, it is. It's the triangulated
There it is,
position.
right there.
Yeah, I think I do. Control Shift, click.
Because if you zoom out,
Shift and click it.
If you zoom out, the curvature should be more visible. And he's zooming out, and curvature is diminishing.
Yeah.
Yes. So this is just it cannot be in real picture.
Yeah.
Cannot
Like he said at the
that.
beginning. He said that once it's done and surveyed, it's done and surveyed. It doesn't matter how you look at it differently. It won't change the structure of the thing. Yeah. Here he is, trying to look at it from a different angle, trying to develop curves into it through a program that Walter Bislin's made. This program didn't exist. That people should be asking themselves that. Like, it's particularly Globers as well. Like, why didn't this program already exist? I'd say because it's not reality. Because programs would already exist in reality for them mapping the thing that they've already got. Walter Bislin shouldn't need to rewrite in programs for it.
And that's the view from the hotel.
Wow, look at that. Does that not look exactly like what we saw during the live stream?
Yeah.
Look at that. That's from the hotel room. So this is all of Jesse's points that he collected from the angle of the triangulated hotel room, because Jesse also triangulated the hotel room while we were there.
Yep. Actually, it's the position of your camera. I nailed that. And like I said, you know, here you can see.
He nailed the position of Soundly's camera.
You know, you don't see when you go down into Manderville. You're
right.
You're below.
That's all below the horizon. That's right. Yeah.
Yeah. I had to roll the windows up.
You want to flood the car, huh?
I had to put it in.
Fucking laughing at him again. Submarine cars.
Amphibious mode. Oh man. No, the next thing we want to do is get those cell towers. You know.
Yeah.
On here.
Absolutely.
No, they won't.
Yeah.
Wow.
I think that's all I had.
That's really amazing, man.
So again, this is the initial presentation of what we have. I do, like I said, I'm making an offer to anybody that wants to. If anybody has some ideas on how to render it in some way or do some animations, that would be cool.
So Jesse, take that link that you're looking at there and put.
Okay, that's enough. Well, we got through it. That's pretty good. There we go. Which is the original plans. It's crazy, isn't it? Amazingly level. To me, I was amazed when I came into this to see that Jesse Kozlowski was trying to push what I saw as absolute ridiculousness, right? But he was allowed to do it. It's the network that Jesse Kozlowski has surrounding him. Mainly, we've got a few people. They tried to come in at the beginning. I think they realise that they can't defend this shit. But you've got Blue Marble Science, you've got Flat Earth Math, you've got FE Dogma. Who else? I mean, there isn't that many others. Stefan Mudd, each trying. That Iridium. Chiquito, or whatever he's called. But there's only about that. That's about 5 people. That's all they've got now. And they can't even come and defend this shit. They just have to stick in the text chat. The Globe guys, the dogmatic Globe guys, have got absolutely nothing. And they won't be able to come and talk about this. Jesse Kozlowski will never come back to defend any of this. They can say that they're meeting him and having dinner with him and talking to him on the phone, but that's a load of bullshit. They know he's not coming back. The lot of them. All useless. And not a skilled man amongst them. Unless you want to try and call them sophists. In which case, they're not very skilled at that either. They cannot have the actual logical argument. So therefore, they'll never be skilled sophists. Because they cannot understand the logical argument to try and trick people around. All they know is the fantasy stuff, the dogmatic model. Just go with what the dogma says and say 'tis globe, and that's it. That's the dogmatic globe model. There's nothing else other than that. State the contradictory things that have to happen and occur within the model, and state them as though you're confident that that's what happens on the globe model. You can just say that. No matter how weird it sounds, you just say it. And it has to be true. Because if it isn't true, then you don't have a globe model, a dogmatic globe model. So, all of these contradictions and stuff has to happen. Jesse Kozlowski knows he's not going to come back. The main surveyor also, he knows he's not going to come back. They're probably still around here at the minute, trying to defend this stuff. But I think there's at some point they're going to have to realise that they can't defend it. They can only defend it against the flat earth guys. Because that's the ever-going, ongoing battle. Flat earth, globe earth, flat earth, globe earth. And we're going to be just pointing it out. Ridiculous. We move on from here because this is Lake Pontchartrain and the hump, obviously. Well, we can contrast this hump now with LIGO, which is a straight line. Most people would think that the lake is a straight line on the bridge. You know, that chord line. That chord line is definitely a straight line. And that goes from one end of the bridge to the other end of the bridge. Jesse Kozlowski in Blue Marble Science says the middle point is 28.5 meters above that line from one end of the bridge to the other end of the bridge. I'd say that's impossible, but you'll have to be aware that LIGO is a straight line. So which one's the elevation profile? how are you going to show? It showed, the bridge showed at 5.7, 5.7, 5.7 all the way across. That was a equal elevation. Yeah, you can always tell where the highest point of the lake is because it's right in the center. Center of all bodies of water have the highest spot. Look at that. Pretty good timing. Do you want to I've been redoing True Level Bitch. I'm gonna go out on that. Yeah. I thought that we might take a couple of days to go over that, but it seemed like we went over it. Pretty good. Just make sure I've got all of these audios going right. Okay. Well, what a day is it? Tuesday tomorrow. I don't know if we're doing anything. Oh, 61 votes. That's good turnout. Will Jesse Kozlowski return to explain the drop of level from horizontal on the dogmatic model? Only 8% think yes. 66% say no. Good number. And 26% say, who the fuck is Jesse Kozlowski?
And that was also my response.
Jesse Kozlowski's the last of the great globe surveyors, the dogmatic globe surveyors, and there'll never be any more. Because you can't fantasize that hard to fantasize a globe model. Geometry will always prove things, and unfortunately for the globe guys, you can always prove falsehoods, especially when people are lying. It will always be showed. Right, I'm going to sign out. This is True Level Bitch, but without all of the ranty stuff, just the pure Buster and Rick and Morty. You guys, can you still see the thingy stream? Yeah. Okay, I'm going to play out, and then we might see you tomorrow. I don't know if we're doing anything. We'll have to see what's going on. Thanks for watching, and we'll be maybe back tomorrow. See if we can do something else on the Jesse Kozlowski files.
See the bubble? I'm familiar with the bubble.
Oh, come on. Oh, has it stopped?
Yeah.
Oh, what? I bet I can't get it back. Yeah, it's not gonna go. Right, I'll have to do a Buster song for... Anyone got any requests? Unfortunately, I haven't saved it or anything yet. Oh, we haven't had a... Model affliction blues. Okay, thank you, God. Super chat. He says, thank you, Bev. Can't be thanking myself. Thank you, gods. Right. Model affliction blues. Sorry about that. I'll get this one fixed up. We'll be on the new true level bitch soon.
All right, here we go. Okay.
Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction, it's your addiction. That model affliction, it brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blue. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. Model affliction, it brings you so much pain. It's your ball and chain.